Ah, we lost her. Willow, stick around. No, lost her. Oh well. Oh well. But I keep that camera for. That's what that one's for. Let's get these things in. This thing should work, by all means. I haven't worked with this hardware in a little bit. We got Hello World working on this thing. And I've been reading, I've been doing my homework, sort of. You know, without the ADHD medication, these low dopamine, good time zones. How's it going here, Bothan? These low dopamine tasks like programming a screen, the things that I grind that take a while for me to do and allow me to move this stream forward are very difficult for me to do. I've wasted a lot of time between last stream and this stream. The insurance thing is in for the prior authorization for a medication that I've been taking for 20 plus years, 30 years almost. Probably, no, it's probably more like 22 years I've been taking this medication. It's the ADHD meds that work. But yeah, so that's gone in. Hopefully it gets approved soon, and then I'll be back on my ADD meds, and I'll be able to do the dumb programming tasks like this thing. This thing I've been reading up a lot about, the U28G2 whatever screen. Oh, let me get YouTube popped out. Dopamine was my childhood nemesis. Yeah, really. A triple the amount a body could handle for more than a decade until doctors finally found a reason for my impulsive aggressions. Weird. Chemicals are weird, man, especially brain chemicals. Brain chemicals are weird. Pop out chat. There we go. Now I've got YouTube chat. I can close that window. And then I need to get my big chat up. Big chat. Where's big chat? That's yesterday's YouTube. There's Twitch. What up, Madam You? Michael Minogue. I don't know how to say that. Minogue. There we go. Michael Minogue. Lawn Dog. How you doing? Looks like Twitch notifications are working. That's interesting that a bunch of people just showed up at once. I'm trying to farm this as the thumbnail. We'll see if that even happens. It'll probably get a picture of me, like, and then that'll end up being the thumbnail. I don't want it to be the thumbnail. After I got the medications, I'm chill as fuck. Yeah, with me, it's more the ADHD fee. I'll just sit in a chair and like tick away at Reddit, trying to get that little dose of dopamine. I can waste whole afternoons doing literally nothing. It's bad. And so this just gives me that little bit of oomph to, you know, get that executive function out the door. You know, it really slaps my executive function. It shoots it in broad daylight and gets it to work properly. It pulls a gun on it outside of a hotel. I mean, no, I'm not playing this song for any particular reason. I'll pull up a more appropriate song, I guess. That's a little crass. This is a little crass, the music that I'm playing. It's very insensitive. Here, let me play this one. This is much more appropriate. YouTubers, of course, can't hear it. It's an audio joke. I don't know if USB is going to be able to power this whole thing. Oh, no, we still have Hello World on this thing. Oh, but it's restarting. Yeah, this is a... Oh, no, it's not. Okay, so that's just a frame rate thing. What you doing, Journey? Hold on, let me go over to the window and read. I want a laser distance numeric meter to attach to a PC by USB that is affordable. Is there such a device? I spent $100 on distance sensors, and the laser distance sensor is unfortunately not sensitive enough for 3D printing, because that would have been a wonderful solution. Here's all the distance sensors. They're all right here. And I played around with a couple of them, but I haven't really gone all in on some of these. This is a pressure sensor too. I mean, there's a lot of sensors up here in this bin. It's gone. Hey, man. Nothing apropos to anything else. It's just a song that I felt like playing. But yeah, I've got a bunch of these like miniature. They're tiny. They're absolutely tiny. They're for cameras and cell phones, a lot of them. And they're very, very small. I don't know how well they work because I haven't had time to put them in anything. This one's kind of my favorite because it's got a very low profile. This one is, in fact, a laser, or it's an infrared, I think, time of flight sensor. But it's got this really cool profile that you could incorporate into something. I should get one of these for my car. But then I'll end up backing into a pole or something because they don't do wide distance. They do very specific distance. I want to use it to assist with loading a camper onto a truck. I have a 1/2 inch of tolerance. That's good. So depending on what you're trying to do, because if you're backing up a vehicle, you know, those laser distance sensors are not good for that because you have like a pole. Let's say there's a pole there. Your laser's going to miss. I mean, your application's very specific, so it might be fine. But using ultrasound is a really good way to do it. And you can buy automotive ultrasound sensors that may be able to blend into a bumper. I don't know, just a thought. You'll have to explore your own application pretty closely, and it's an easy thing to do. It's actually a fairly easy thing to do as a distance sensor of some kind. Nothing's working in my Discord. The username, nothing's working. Working on that very thing, sort of. They've got a pressure sensor that they have in their car on one of the gauges, and that pressure sensor could be used to do a bunch of other stuff. You could make a little menu for it, which is kind of where we're heading with this. I've been reading about nothing but menus for the past couple days, and they're weird and hard to implement for some reason, and everybody does it a different way. Is it possible to make a 3D printer without a stepping motor? Yeah, of course. Stepper motors are just one of many types of motors. You could do it with geared motors if you really wanted to, if you really wanted to fight that hard to not use a stepper motor, which is kind of silly because stepper motors are very good at what they do and they're cheap. But if you didn't want to use a stepper motor, you could do what printers do. Regular 2D printers. What they do is they have geared motors and geared universal DC motors, and they just yeet the thing from one end to the other, right? They just yeet that thing across. And what there is a Mylar strip with like hatches on it that are sensed by an optical sensor. So that apparently is much cheaper than putting in stepper motors. All the old technology that I used to take apart from like the 90s had stepper motors in it. They don't do that anymore because they're too expensive. Universal DC motor, gearbox, out of plastic, strip of Mylar, Bob's your uncle, right? Easy peasy lemon squeezy. So that's one way to do it. The other way is if you really want those motors to know where they are, because they know where they aren't, you can use 3-phase motors as stepper motors. 3-phase hobby motors have been going down in cost pretty universally. And actually, there's some gear drive motors that I was looking at for burn the subs to do like hardcore robotics on it. There are these universal drive, these 3-phase hobby motors you can strap an encoder to, and then it becomes what's called a servo. So the servo knows where it is because it knows where it isn't. But then, yeah, those have been going down in cost. Straight up robotics motors that already have sort of a gear reduction in them are also these like pancake gear assembly kind of things. Very cool, but they sort of have a sensor in them. So you can use that kind of stuff in order to build a 3D printer. All 3D printer does is move, you know, the thing in an intelligent manner. You can accomplish that with a lot of different technologies. It just turns out stepper motors are easy and cheap. And fewer parts to go wrong, whatnot. Really easy. Camper goes to the back of the truck bed. Last time I scraped the camper along the inside of the truck. Oh God. you can get just like an Arduino starter kit for a distance sensor that will have, you know, it might have an LCD, it might have some other way to display distance, but like an Arduino distance sensing starter kit, and it'll come with something that looks a lot like, like, looks a lot. It looks a, hold on, okay, okay. It looks a lot like this, and this is just a little ultrasonic distance sensor, and this will get you within an inch for sure. I think it'll do a ½ inch easily. We've played with these before. You know, you can just have it print out the distance after reading the sensor. The sensor has a particular way to read it, but these things are all over the place. Like, there's 1,001 projects that use these things. So these are easy, these are cheap. You can just get it and strap it in, and Bob's your uncle. There you go. You'll be distance sensing in no time. You don't really need to get to the advanced laser stuff unless you want a specific point, a really specific point. I think when moving vehicles around, something like the ultrasonic sensor is going to give you a little bit wider of a field, and it'll give you a little bit more detail about what you're doing. But yeah, I mean, that's a righteous project. That's a nice, easy one to do. You have the same time of flight sensor. Some of the ones that I haven't had any use for time of flight, but some of the ones that I've got are like cool. There's like some cool sensors in there that I would really love to use on something, but yeah. Why is this getting warm? The problem is these things take up a lot of current. They take up a lot of the 3 volts that this thing has available to it. So I'm probably going to need to run the external power supply, and we're gonna muck around at this thing a little bit and see what we can get working and running, which means I probably need the oscilloscope functional too. And that'll give us a bunch of different signals. I'm getting bogged down in the menu stuff. I've read about menus for quite some time because I'm eventually going to have to make a functional menu for the module tester module. This is a crutch. This is just a Eurorack powered frequency generator. There's no input sensing, and I know what the menu should look like, although maybe I want to be a little bit more artistic with it than with the other menus that I've programmed, but I sort of have a plan. I would like to be able to change the waveform frequency and amplitude of all 6 of the channels in here using the screen only. So I can plug this end into Eurorack and then not have to think about plugging the computer in or any of the audio tools. But we need to get this pumping out waveforms, and I need to tune all of the outputs. So we're going to use the scope, which has been booting up for a year. And by the way, last stream, we set to update the software on the scope. It did not update. It didn't do anything. It's plugged in with Ethernet. It has plenty of internet to run off of, but it just sat there and load. I'd like to have a word with Rygal about that. I probably have to download an update. They probably unscrewed up a lot of their updating stuff with an update that you probably have to apply by not using the online updating stuff. Yeah, I'm happy to give tips. It makes me sound smarter. Hey, what up, esports? How you doing? I had to update mine through a thumb drive. Yeah, that sounds about right. Does it take over the whole thumb drive? Do I need a dedicated thumb drive? I'm so sick of thumb drives. This has literally on the screen a thing to update. Here, where's that? Scope overlay. That's overlays. No, we're above overlays. I've got so many things in OBS. I really need to update OBS and remake a lot of my scenes. So in this menu, I have update, and there's a red circle on it. Update.gel. Go. Oh, look, it actually worked. That's rare. Well, we're going to do the update and brick my scope. They wanted me to do it. They say upgrading, but I doubt it's going to upgrade anything. I think it's just going to update the software. Or it's going to do this forever. I don't think this is not what it did before. Before it just said updating and then didn't do anything. Now it's actually got like a file name up there. And it says upgrading, please wait. Oh, what happened there? Oh, it's one of those little points where it repeats. Yeah, could you imagine? Wait, what just happened? Now it's not updating. Click OK. Accept. Did the number change? Do I have to go through a chain of updates? Maybe I have to click on it. Seems like it's not doing anything. We'll let it think about what it's done. No, it's telling me to please wait. It's not telling me okay. Okay is shaded out, yeah. Huh? It just doesn't give me, can I click on this? It just won't take the software. What's the deal? What's going on here? Upgrade. DHO 9000 update.del. And I click OK, and then it makes me sit here like a sucker for a little while. Okay, there's the agreement. Via the entered, and then it's cut off. In order to ensure the smooth process of online upgrading process necessary to network and collect the process following local information, device information, MAC address, ID. Well, what? Device status, including power running status, blah, blah, blah. Clicking agree. I'm actually clicking accept, not agree. And there's no other, like... This is shit. This is such shit. Look, the agreement that I'm clicking on is off the page. There's no way that they could legally defend that. Click accept. And then it pulls me to this menu. So OK is blurred out for this. And it just says, upgrading, please wait. I'm going to restart the scope after this one and see if it does anything. This is the third time that I've clicked on it. I mean, they want specific data that the scope has about itself. I don't know if there's too much issue with that. Yeah, it's, I mean, look, they're all collecting all this fucking data. There's nothing I can really do about that. We're 18 minutes in. I think I can curse. Nothing specific about the song that I'm playing, though, for those on Twitch. Okay. You view the scope logs. I guess, if I can figure out how to get there. The clicking on the screen thing wasn't happening so much with the other firmware, so I was hoping that this update would carry with it a little bit more stability to my screen and clicking, but are we good? What are you doing? And the air is all clear. Come on, Scope, you can do it! I like how their color scheme is translucent gray over top of gray. It really is kind of depressing. I mean, it's nice that it's night mode, but you can throw a little bit of design into that. Yeah, the stability update is too unstable. Revert to a previous working copy. I'm not, no. It hasn't done anything. The scope still works just fine. The screen's just a little punchy at times. And I think it's better now. I don't know. It was working better now. Before, I wasn't even able to get that file name in there. It just kind of held up on this screen for 3 days. So maybe I do need to reboot. Clearly, it's stuck on something. Oh, the window just goes away. All right. Let's see. XY ref record upgrade utility. You guys get all my network information. 192.168.1.1. Oh my god. IO setup. That's fine. About. That's all my model name and firmware. Open source acknowledgement. Oh, this is their open source app? That's kind of cool. Options. Quick access. Well, I can self-calibrate. Oh, look at that. Computer serial trigger analysis, RS-232 and UART I've got forever. Auto serial bus trigger and analysis and embedded serial bus trigger analysis. What I don't have is 125 megahertz to 250 megahertz bandwidth upgrade, which is a soft upgrade, and I could probably get that online with a little bit of Googling. I don't know if there are logs. I'm closing this. We're going to reboot. Oh, I guess if I double tap power, it immediately shuts off. Do you think electricity is fully solved, or does it have still some mysterious behaviors? The relationship between electricity and magnetism has been studied to death, and we know it extremely well to the furthering of our technological abilities as a society. We have done a lot of due diligence in that manner, but power generation, we're still kind of converting steam into spinny thing for most everything. When we spin stuff, we can make electricity. It's still pretty rudimentary. There was actually a really cool fusion technology that I think the who's that one guy? Hey, Fadanon, thank you so much for 69 months. Nice. 69 months. Thank you so much. And that's it. Holy crap, dude. That's a tier 3. You don't have to do a tier 3, man. You don't have to do that. It's very nice of you. They've been following battery technology. Not really. We do need better batteries. But there was one where they're using like electromagnetic fields in order to throw two things of like deuterium or whatever at each other, and it makes a bunch of little, what the hell happened with this? What's going on there? That's a weird one. But they were throwing them together, and that would make a dissipating magnetic field in the presence of a coil, and they had banks and banks of capacitors in order to store it. I thought that was pretty cool. It's not saying I need to update anymore. Maybe it's already applied the update with the restart. Whatever the hell's happening to, oh yeah, Willow was down here. As soon as I start broadcasting, she leaves. So, oh, let me go back to my other music. There we go. It's like steam, and then we're really, really good, like technologically, we are really good at getting all of the energy out of heat, out of steam heat, because steam holds a whole lot of energy in it. Water is very difficult to manipulate and change the temperature of. So we use glowing rocks in order to make that steam, but we were already really good at getting energy out of steam. And so we're getting every single little, yeah, helion, that was the, but yeah, every single little ounce of energy out of that water so that we can put it back into the system and it can boil again with all that energy. But that spins a huge turbine. We're really good at making turbines. So that ends up being sort of the dominant technology. All right, this thing is better now. That we, you know, it's like aliens could drop down on the planet and go, here is a new technology. It's magical. And we're like, well, what kind of heat does it produce? Because we're going to boil water with it. And extract 98% of the energy in it through boiling water. And it's like, could you guys stop doing that? No. We're too good at it. Too good at boiling water. But it was cool to see that reactor where they're throwing they're throwing plasma at plasma and making it collide and create a magnetic field that would dissipate, because that's a cool thing. It's a direct to energy kind of dealio. LifePo batteries are apparently less likely to torch your house if you're storing solar power. LifePos like to be hot too. LifePos are very good batteries. I like them a lot. I was going to use them in a couple e-bike projects that never kind of left the ground. They handle cold good and have super long lifetime. LiFePos can get cold. Batteries hate getting cold. That's one thing about batteries that I think the non-engineer doesn't quite understand. Like, they're chemical reactions, and so the reaction's going to reaction better when it's warm. And so LiFePos really like to get warm. Like, if you're using those batteries in the desert, you're in a good place. They don't have as much energy density as LiFePo. I see. Well, those are the LiFePos are like the torture battery. They do really well in adverse situations. Is my understanding. I, of course, could be wrong. After mastering nuclears, I've learned a ton about light water reactors. I have not played nuclears since I did the stream, which was fun, and I had a really good time. It was very overwhelming learning that much about how to run a reactor like that solo. The battery can't have any life. Why do you call it LiFePo? Lithium iron phosphate 4. I don't know, that's just what I call it, man. General Fusion went funky with their second design. What's General Fusion doing? See, I'm not up to date about all that stuff. That's iron phosphate oxygen. I was close. I was doing that from memory. I need to open my software. The stuff that I was programming. Oh, I guess it's in here. Oh no, that's desktop. See, I was working, my other computer can write to the drive. This one can't. And I don't know what's wrong. It's permissions inside of, what you call it? Permissions inside of TrueNAS. Oh, that's not what I thought it was. I thought it was just going to be a picture of Big Yoshi. Those are measurements for a project that never got off the ground. I would have loved to make the cheatingest Mario Kart home circuit, the little RC car, the 24th scale RC car, and send it to Djibouti Show and have them do it on air. But, you know, they struck while the anvil was hot on that Mario Kart stuff, and now it's kind of like old news. So there's not too much stuff going on with that. It's not sort of going to grow your audience doing anything with that. I'm very sad about that. But, you know, as we do here, we took too much of a bite out of it and tried to engineer it a little bit too much. And I ended up on a whole diatribe with RC cars to the point where I've got this thing sitting here. And I just actually got in the mail a sort of a dirty white filament. It's not like a brilliant white like these wheels are. It's sort of like a dirty white. It's a cloudy white. And so that's probably going to show a lot of the detail on this a lot better. I didn't want this to be that sort of like sterile white plastic look. I wanted it to be a little bit more gray, but like it's Lancia. It needs to be sort of a striking color. So it's this or yellow. Actually, this would look pretty good yellow, to be honest. But I want to, at some point, we're going to do an AutoCAD sponsored stream, and we'll try to actually make light housings for the front and back and see if we can get this thing to have LEDs in it. That'll be headlights and taillights. YouTube suggested me a video about printing RC car shells. Was it my channel? Because we did use a little bit of AutoCAD to try to make that shell, and I've come up with a system for that, but I thought that was red. What? Glue it with hot staples. No, I already know what I'm gonna do. You guys, what? What are you trying to do here? What's up, fire safety? I could get red, but this Lancia, actually, yeah, this Lancia was red. This was a red car, you're right. But I want to do something else. You know, I'm not gonna. The only reason I use Lancia in this case is that the wheelbase is so wide that it fits this really well. What's up, Gonad? Good morning. At least it's kind of morning in Cali. This is Pennsylvania, so we are well into the afternoon. I decided to do afternoon streams at this time, not because of any sort of perceived audience, because I would do a lot better if I did evening streams. Let me tell you something. I do it at this time so that I don't waste my day. So I end up doing smart stuff in the middle of the day. This is a motivator. It was somebody else. I'd love to see it. Yeah. Yellow makes it go faster. It makes it look better because outside of here. I have our neighborhood is like a private circle, right? Our neighborhood's like a private circle, and so you build something like this and you put it out there on the blacktop, and it's not black, it's gray, and so it's wintertime in Pennsylvania, and so it's overcast pretty much the whole time. That's just New England, and so it's overcast and gray, and all the leaves have fallen off of all the trees out of spite, and you drive around your gray RC car on gray blacktop, and it's just very depressing. So I need to like get a color onto this thing. I'm gonna make it white, but I will consider if I should order red or yellow filament, not filament, goo. Home of the great Jimmy Pickles. What does Jimmy Pickles do? You hear about Pennsylvania a lot, and sometimes it's derogatory, and other times it's interesting to find out, like, oh, this person is from Pennsylvania, or oh, this person. I mean, we're in Philly, so. What am I how am I supposed to say Lancia? Lancia. You know, whatever, man. I'm American. How windy is it there? It's gusty. Our power has been flickering, so if my power goes out, stream ends. That's my policy. You guys know that. Should know that. Power goes out, stream ends, because you know our internet will go out eventually. It might come back in like a startle, but usually that just means the stream's over. So, and if power goes out, I've got a couple minutes too, because everything's on battery backups, and then we have a generator. We bought a generator because the power here just goes out all the time. Our power is on lines, and they've cut away a lot of the foliage from the lines, but it's only a matter of time. I've read a couple of times, and it was a disappointing shade, like bright green. Oh yeah. Well, the problem with bright, so okay, 3D printing. Bright green is all well and good. Gray is really my best prototype color, just because it's consistent. Not that you're gonna have a lot of inconsistency with the colors of the 3D print stuff. Yeah, the camera, that's the thing. The bright colors, the camera does all of its adjustment settings, and this will end up looking like it's glowing. So I prefer to use darker shades, and I prefer to use grays, because the camera really likes gray. That's why the mats are gray. When the mats weren't gray, when these were green, I would have a hand in front of the mat, and it would look like I'm about to explode with blood pressure, because my hands were like red, because the camera goes, that's a lot of green, let's dial that back a little bit, and then it ended up favoring red. Gray hides layer lines. Doesn't it? I thought, for me, gray shows everything. It shows absolutely everything. And so you don't get away with something like on a red, where it might blend together a little bit. Instead, with gray, it's just all right there. That's my impression. Starlink. I don't have Starlink. We have Fios, the other big evil. But it's very fast internet now. They forced us to upgrade, which is why I'm wondering why Groovy Something hasn't been forced to upgrade yet. Why haven't you been forced to upgrade your internet stuff? Verizon's going around and forcing the upgrade on everyone. Yeah. They're making everybody get the new technologies so they can track you or something like that. You know what they do. You know how they do. Wait, did you upgrade? Nice. So you actually have normal internet speed now? Groovy used to have like 2 up. It was horribly frustrating to watch as another Verizon customer. But yeah, so what happens is our internet will stay up for about like 5 minutes after the power goes out, and then something somewhere else is shut down, and then the internet drops. They stopped giving service to the old router. Okay, so those upgrades were more universal than I thought they were. Well, it's good. You've good internet now. Hey. I really need to print out the other car body. That's good. Yeah, unfortunately, I have my own intranet. So my internet goes through my own router equipment, and then to the Verizon router equipment, and then out to the regular world. So there's a bit of a slowdown on that process, and especially my gaming computer, which again, gaming doesn't need high-speed internet, but whatever. The computer that I do everything on has a really long wire that goes around like the room almost entirely, and so that slows things down even more. So we have good, like great internet. It's just I can't utilize all of it. Basement Wi-Fi. Oh my God. These houses, for some reason, 90s construction in these houses means that the Wi-Fi barely goes through walls. And so I have high gain antennas down here. That manages to almost go up to the third floor, but well, third floor from where I am, the second floor of the house. What I do is I've got one of those power line things where you plug it into we have a cable that goes all the way upstairs, but then it plugs into one of those power things that puts Wi-Fi on the ground wire of our power, and then in that floor I send it to another room where I have two repeaters that are doing Wi-Fi repetition for the two networks here, and I still barely get a signal outside. That's in the front corner of the house, and I'll be standing out on the road outside and barely get Wi-Fi. It's ridiculous. I think I need to look into something like Ubiquity. They're expensive though. They're really expensive, but my friends have had really, really good luck with them. Yeah, Ethernet over power line. It's cursed. It's cursed. I think with a little bit better equipment, I could do much better for this house and have less stuff to constantly maintain. They used to get 3. Oh. Is that 3D filament printed? This is goop printed. This is done with goop. This stuff, the little add-ons that are structural, that's done with a filament printer, because the PETG is very strong. It's good for structural engineering stuff. So this RC car is a professional RC. It's like a $200 kit that I bought as a means to calm myself down. I bought this because I got very mad at the 1/24th scale RC car stuff that I was messing with. It was like the $75 kit that you can get on Amazon, and it was almost there, and I had a 3D model of everything, and I was putting stuff together, and it just something broke, and I got very mad. So I bought the professional kit just to see what it was like on the other side, and it turns out it's very, very nice. It's very easy to build, and so I designed not the circuit boards, but the thing that's holding the circuit board. So instead of the stabilization piece of carbon fiber here, I turned it into a tub for a bunch of very specific DOS microelectronics. So, hey, you know, if I was going to go professional with this thing, I would actually probably do pretty well. Although this is all-wheel drive, and the professionals are like, it's like a little wing that you drive around. So whatever, I'm doing it for fun. I'm doing it for fun. And so to the shock tower, I decided that I would have the body mounts, but instead I'm using a magnetic connector. It's a mag-safe connector, and these hold pretty strongly, and they've got these little pogo pins. So I have 6 pins that I can use to send a signal to the top half of the car. And it's kind of a cool way to hold it together, too. This is a GPS unit inside of there. But you basically line up the rear, and that kind of snaps into place, and then the front snaps down, and it holds the entire car body on. We've been doing a lot of 3D modeling with this thing. So I'm trying to get it all straight. We'll return to it soon. I got some new filament, so I can print out another car body. You should add a Wi-Fi camera. I don't have a Wi-Fi camera, but Louis, Lunatic Live, if you guys are interested, you guys should check out Lunatic Live. He's one of the Djibouti boys, and he, I mean, he does his fair share of giant man-baby stuff, like I do, and he suggested to me one of the little cameras. Making a mount for it might be a little challenging. I'd have to do, of course, a cutout in the windshield, but it would be kind of fun to have a camera on it. Have you done FPV Dog yet? I haven't, because that thing gets hot. It gets very, very hot, and I don't think Willow would appreciate that. I could get one of those like micro GoPros, but I don't have the money for that kind of thing. To make it more aerodynamic. It's already really aerodynamic. What are you talking about? This is, I mean, a Barth kind of flies in the face of aerodynamics, because what they do is they open up the trunk and they go, that would make a good wing. Some of them don't get warm. I'll have to see. Yeah, at some point, if the technology gets there with Wi-Fi, we can do an FPV Dog camera. But she didn't sign any forms. She doesn't know how to hold a pen. So I don't know. And then she'll walk around the house, and like we'll be able to see people that I don't think consent to being filmed. So it's the right thing to do to not film people. I addressed fire safety in Moore's. Good morning. No opposable thumbs. Yeah, she needs a special kind of pen, and we just haven't taught her that yet. when I was doing the high speed runs with this, and because there's a gyro in this that'll stabilize it, I can get up to, well, I don't know what speed with the gyro. Without the gyro, I can get up to 35 miles an hour, which is 55 and I think a half kilometers per hour. 35 miles an hour, which is like polite neighborhood speed. It is wild when it gets that fast without the gyro. I enabled the gyro, put the body on, got a good run in, 2 good runs, and then it crashed and broke in half because I made this a millimeter thick. I don't want it to be strong. I want it to explode. I think it's funny. This stuff won't explode, the PETG. It'll strip the screws. So I would rather have this thing blow up into a million pieces because it's funny. But I looked at the run and it said no satellites found. So I didn't end up getting a good idea, a good impression of the top speed. This is the top speed setup. I'm using a Lancia body. It has a little wing on it. Before, what I did with this setup is I attached a spoiler to the front and the rear. And those actually made a difference. There was actually, the car was a little bit more grippy with the front and rear spoiler. The aerodynamics is actually a thing at the speeds this thing can go. You can give it cool stitches. I thought about doing that. I kind of wanted to do the stitch thing, but then I saw that there are significant pieces of it that are missing. And the whole point is I can 3D print it. It only takes 4 hours to print out the body. It is a sizable print. It's a long print. 4 hours for the body, and then I have to dunk it in alcohol in order to get rid of the excessive goop, and then I have to put it in sun or put my grow light right on top of it and let it cure, and then I can do the details like just, coloring in the glass so that it looks like a car. I would like to make this stuff out of clear resin as a separate piece so that the car can instead be 2 different prints, but that would mean strengthening all the different, A pillar and D pillar and C pillar. Yeah, I mean, multiple prints, but I don't want to, as modular as this thing can be, I don't want it to be fully super duper modular. What I want is headlights and taillights and glass. That's all. So we'll spend a little bit of time working on that. I think Fusion 360 should make that relatively painless, moderately painless, maybe a little painful, but not much. I should be getting some UVB LED tape. Oh, that's cool. Wait, so they sell that as tape. The visible light illumination, like the 4300K tape, is really cool. I used it in the Burn the Subs board. I still haven't wired up the USB for that, but that'll light up on its own. It'll look really cool, kind of like a museum piece. I should probably put that like over here, somewhere that you guys are gonna see it. Or if I had like a face cam, if I put it parallel to the wall instead of behind my computer, it could be a good backdrop. What? I'm just playing Filter. Nice shot, man. The song about a politician that axes themselves on live TV. What do you mean? Should I put back on the healthcare company hold music? Good song. This would play at every sports stadium ever, all the time. Every sports game, they'd play this song once. Not this version. This is the 2009 rewrite or whatever. They kind of updated. But every sports game would play this freaking song. Like, why am I'm watching lacrosse. Why is this song playing? We'll go back to hold music. But yeah, headlights and taillights would be really cool because there's something on the controller that would allow me when braking to have the taillights come on, and then I would be able to do 2 different headlights with the amount of pins that I have going to the upper part. And that's all powered directly from the, whatchamacallit, it's directly from the radio. The radio has 10 channels. So the other thing would be, do I want the headlights to be functional? And if I were to do that, I could have low and high beams, and I could use like serious white LEDs on the high beams so that this thing you'd actually be able to see in front of it. I thought that would be very funny. If I can embed like a little circuit board back here, because all the lights on the Lancia are clustered. there's 3 here, and then there's 3 here. And there's also reverse lights. I don't know if I'd be able to do the full reverse light, but it would be kind of hilarious if I could. Enough pins to put a light bar. I don't want to do a light bar. I have little sirens. That would be funny to do like a tow truck. But I don't know if the radio supports like reverse lights. I think it does do something for brake lights. And then depending, I mean, like I could take, what is it? I have 6 pins, right? So if I don't have to send it power, but it might not be enough power. So, I mean, positive, negative, channel 1, 2, and 3. It's only 3 channels. So brakes, reverse lights, headlights, brights. That's 4. So I'd have to sacrifice one of them if I have to send full power out to like a transistor board somewhere on here. There's no means by which to do digital communication between the two on that radio. Of course, I could make it any power at all would just make the low beams come on. The low beams could just always have to be on. That's probably a good way to do it, because if I send power over, I can have low beams are always on, and then the other pin will activate high beams. And then, I don't know about the fog lights. Yeah, lights is a power indicator. They start dimming when the battery goes low. Send binary over the low beams and just have the microcontroller decode it. Well, I mean, yeah, as great as that is, I mean, I could do some form of communication. It is, after all, just sending servo signals. And so I could code the servo signal to be like 50% is this, 100% is that. But that's a lot of work. I'm not looking to. I'm already inundated with work with this Hello World crap. Speaking of which, we should probably get started. I mean, theory crafting about what I could do with the RC car is great, but I would rather have simple solutions in place instead of doing something crazy. Yeah, but we're starting to put in modules and considering the benefits of CAN bus, which is not a place I'd like to be. I didn't do the micro procedure. The colors are all wrong. Sorry, that was a burp. I didn't have time to mute. There we are. Beautiful. Hello, world. Let's get the hold music out of here. I'm giving up on this phone call. How's everybody today? How we doing? Crazy times in our world, but we're gonna kind of slink away from all that for a little bit and catch up with it later. In the meantime, we're gonna work on either screens or let's just like tune this thing. What I've done over the past couple of weeks is I've built a unit to test the mixer, because I need signals. I need signals to mix. And I need them to be at Eurorack audio levels, which is plus minus 10 volts. That's a lot of volts. That's a lot of volts to be pushing around. So we put together the hardware for this thing. I decided that since I had this huge pin header attaching everything to this, that I would just dedicate a little space at the very end for a screen. Unfortunately, screens in this show are somewhat cursed. The refresh rate is weird, and so it doesn't really agree with the camera. Some of the times, my refresh rate for these webcams changes as the scene changes, as bright and dim are sort of interpreted through the camera. It'll change its frame rate to have the maximum number of frames available to it. It's a Logitech camera. These cameras are not great. I would love to get great cameras, but I just don't have the budget. And the simple Logitech cameras I can get brilliant 1080p, 60 FPS video out of. It's quite beautiful, but anyway, that comes up with the cost of slight frame rate issues on some screens. I put the screen there just because I have a ton of screens. I have a couple projects that are sort of stagnated around building synthesizer modules to have displays, and since we have 6 channels here of output that are available to us, it would be nice to be able to configure a little bit without having to plug this thing into a computer. So I have been looking into screen software for these modular synthesizers. So my module tester, I believe, is the one that I've been working on. Yeah, wait, 4:25 p.m. That doesn't make sense. 11:29. No, this should be 12.2, 12.5. I thought I saved it into, oh, this is the desktop. Oh, right. I need to get into my drive. That's what's going on. So project, stream, module, no, synth. Ah, geez. Why do I do this with titles? I always come up with these irreverent titles, and everything's always not where I wanted it. So yeah, these OLED screens has got a kind of a cool monochrome look to it. It's yellow. I think I can also do blue on this one. I think, but I would have to test that somewhere. I have been completely buried in learning how to make screens do stuff. So where is that? That's the mix amp. Speak and spell, public, Pico DSP, output screen menu. Here we go. So module tester, 12.5, 11:52 a.m. That's today. Okay, good. So I was just working on this one. The library that I want to use is the U2G. Well, I have to remind myself what the name of the module, what the name of the library is. It helps you do these screens. And it kind of is weird. It's got its own like definitions of how stuff is supposed to go together. I made a couple little breakthroughs with it using, oh, here we go. New version of Arduino, no. So I am using U8G2 lib.h. It's a U8G2, it's a screen library. It has tons of available screens that you can actually program with it. Why is, I'm noticing, okay, no, the delay's gone. Okay, there was like a delay between my mouth moving and the words coming out of my face. And I'm also using U8G2. It's just like a miniature U8G2 thing. Did I mark it down? I thought I had it up here. Yeah, minimum UI. Minimum UI allows you to call functions that will make the different graphical interfaces that you want to use. So what, oh, this is in light mode for some reason. So like you can make these comprehensive menus with settings in them. This is pretty much exactly what I want to do right here, the selection combo box for frequency. And then I want to have like a numerical thing below that, et cetera, et cetera. It's a little bit eclectic though. You have to kind of like learn how their example works. And I've been reading through that and not really understanding a lot and sort of jotting things down as I go. What I want to do today is hardware, and I'm actually going to have to use the bathroom in just a second, so you guys will have to humor me on this. But what I'd like to do is just use the audio tools, the teensy audio tools, to make a 6-channel output. We've done this before. We've done this on the breadboard, but I want to make this 6-channel output so that we can work on the actual mixer itself. And then in the meantime, this is a lot of bookwork that's not going to look really good on camera. So I'm going to do the bookwork separately. But anyway, my guts are about to invert. So let's put this back up. I wish I could have like a technical output on this thing that would show stuff. Like if I could, well, that's a totally different robot in and of itself, but I would like to at some point get one of these screens displaying chat. That would be very neat to do. And we can do that through Node-RED. I found what the node is supposed to be. But in the meantime, I'm just going to put you guys on hold. And oops, wait, I closed that window. Control-Shift-T. Control-Shift-T. No, we don't want filter. Pause. We want this one. And then I'm just going to mute. Oh yeah, I need to put up a BRB. BRB. And then where'd that overlay go? Oh. Nope, that didn't work. I think my my overlays are a little bit broken, so we'll just leave that up. I'll be right back, chat. And then we'll get to making this thing do stuff. All right, I'm back. Sorry, I guess turkey chili isn't quite agreeing with me very well. How's everybody doing? Okay, so I want to get this screen running. We have a particular module in this. Why is there an insulin bottle? Just I'll put that over there. I want to get 6 channels of output out of this thing. The way to do that is to use the PJRC audio tools. So I think I still have them open. Yeah. Basically what we want to do is just tell, let's see, that project ended up not being what I was looking for. Although it's okay. It's good for inspiration. But yeah, we got all the wire stuff hooked up. We figured out the structure of the schematic and all that stuff. It's here that we want to be messing around. And what we have is we have I2S running to an, what is it? I think it's ADS 1113 or something. Let's see. It is a, oh, I love how it doesn't tell you. What? Butt change? Yeah. You got to call things irreverent. PCMS 10102. Oh, sorry. PCM 5102. PCM 5102. This is an I2S audio output module, and it goes into a TL072 where we boost it up to plus minus 10 volts so that we can pretty much make anything from DC to daylight. We can't do light frequencies, but we can do anything to do with DC and AC signaling. We can output out of this thing. I can get this to do a DC level if I need to. And so we do that using these PJRC audio tools. It actually, we don't really need this tool specifically because our waveforms can get defined by something else. We'll have it like into a different system. Proteus, thank you for subbing. Thank you, Proteus. I appreciate all these resubs coming in today. What's the message here? Hello, hello. Yes, hello to you as well. What's up, RYG? How you doing? So, yeah, this is pretty simple, and this is on my kind of level where we just do whatever, right? It's just whatever. It's whatever. It's so easy. We already made an example with this, so let me open that up. Which one is that going to be? The module, not Hello World, Blink serial pass through. It's somewhere over here. I think it's the other module tester. I just want to get waveforms out of this thing so that I can tune it and have it available to work. And in the meantime, we'll start to figure things out with screens. I want to use this minimum UI, and there's some weird things about it that I still need to learn, and maybe we can get to the point where we're actually testing it. But this thing is pretty cool. I mean, you can make some really cool menus with it. The only problem is I did not see an example that had a float in the enter thing, and I looked up whether or not float was in the list of sort of easy entry types that you can do with this software. It wasn't there. There was one where you can manipulate the duration and sort of amplitude of a complex waveform. So that's in there. I can just make that as part of my thing. It's actually kind of awesome. The MUI reference is where I'm looking, and it's like U8, uint 8. This is all we get is U and 8. There's no float. And this also has images of the examples, which is pretty cool. I like this. This is very comprehensive. You can have a bar that'll adjust, you know, your amplitude or something like that. I can do any of a number of things with this system. The only problem is I didn't find something that handles float as an input. Maybe we can trick it. I don't know. Or I could do like specific note outputs. But for the time being, we need to do this on our own. So what we will do is go to the 6-channel output test file here that we've already done. We've already done this. So module test. These titles are getting very confusing. I don't know what it is about that turkey chili. It's like going right through me, and I can feel another visit to the bathroom coming on. I think I'll be okay, but it's annoying. I gotta hydrate. I feel perfectly fine. Ugh, every time, new version, new version. So in the audio tools, what basically happens is you can output from this picture here, from this diagram. You can make your diagram kind of like Node-RED, and that'll have your ins and outs on it, right? So I2S in is actually a different block that I can put down, which is how our final tester is going to work. This is sort of an interim tester in order to get these other projects underway. So this one will only output, which means it's exactly what we see here. And so what I've got are these blocks that I can drop with I2S. I can drop blocks with waveforms, SPDIF, all kinds of stuff, DC, et cetera, et cetera, et cetera. And then you output this to, oh my God, my dog will not stop barking. Willow! Jeez. She is just going at it. You can export this to a file, and the way that the file handles all of that stuff is by having connections. And so it's got like an XY plot. That's not really relevant information, but what it'll do is it'll say, you know, this waveform goes to this patch. It's patch cording things together like they were actual audio devices. So patch cord, waveform 3 to port 0, I2S oct 1 to port 4. That's how it works. It's just point to point. So you don't really even need the visual diagram. You could just write that up. I have a little space here where we'll inject some of the screen code and then set up audio memory and then define your waveform. So in this case, waveform sign, we of course can call that again depending on what the settings are on the screen. So we can edit a variable, tell our software that a variable's been edited, and when that's detected, it will go in and make the edit by calling up waveform 1 begin. And it'll give it all the properties that are in our little structure that we've set up for each individual waveform. And so we can do that with 6 channels, and it can be relatively code light depending on how MUI goes together. For now, let's just take some of the properties of our hello world and put that in. So hello world with the screen examples, we're going to paste into our module test, and we'll make that all happy. The pins that I'm using are set pins because I2S has 2 channels, I2S1, I2S2. I2S1 has channel A, B, C, and D. We're using A, C, and D. No, yeah, A, C, and D. Channel B is actually populated. It has pins, but they're on the underside of the board, and you have to solder to a pad that's on the PCB, and I just don't want to do that. I don't want to do that. So we're using 3 channels, 2, 4, 6. We could have 8, doesn't matter. We'll have 6 channel output. I don't think anything that I have needs more than 6 channels. My dog is going nuts at the door. I really wish somebody would handle that, but nope. I'm just hearing a lot of dog barking. So we're interested in hello world. This is not hello world. This is me trying to write the final piece of software. We need something simple just to put text up on the screen. And just outputting waveforms, I think is what will make it say. So we're using U8G2lib. I don't know if Arduino.h needs to be in there. We have audio.h called here. SPI too? Huh. We have wire and SPI both being called for this. Serial speed is 115200. I guess we're defining that for some reason. ANV test, audio memory. Okay, so we're coming down here, and U8G2 library has a couple things that it supports. It supports a few screens, just a few. Just a couple screens, just a few, and a couple different configurations. Just a very minimal amount. Oh, there's the code. Jeez. So we need to find our screen, and lucky for us, we are on a sort of unknown and no name 128 by 64 OLED. So we're pretty much like the first line. We need to find I2C. Here we go. U8G2, no name I2C. Reset is no pin. And U8G2R0 is, I believe, full RAM. So we're going to call that all the way up here. Actually, wait, where are we? Yeah, we'll call it all the way up here. This is a good spot for it. GUI tool, end automatically generated. Let's get rid of that. Begin automatically generated. All right, whatever. So there we're calling the U8G2 screen. We need a couple, actually, we need a couple settings for my other, the one that I closed, which would be module testers. I think that's it. I'm going to grab a couple of the pinouts from this. This old busted IDE is a chore to use, but I like the simplicity. I'll have to move to the new IDE at some point. But yeah, here are all of our pins. So pins and settings. I'm setting up bounce, but I don't think I'm going to use bounce at the moment. I'll just put these in there. We're not really going to use them. Button change. We're not using that at the moment. Bounce settings. This is the one that I set out. That's going to use I2C 0. So those pins are fixed. Yeah, and I guess I don't need any of the other stuff. Okay, so we're going to go back to setting up the screen. I really didn't need to incorporate pins in here. I don't know what I was thinking. Okay, so we go all the way down to the bottom. So many screens. U8G2 begin. I guess this is where we would define buttons for the U8G2 screen. Or I can use my own buttons to go through stuff. But I don't know, with the minimum UI, I'm not sure what I need to do with that. Put your setup code here to run once. Delete. Audio. Why did the O key not... Audio. Audio. My O key doesn't work. That's annoying. Pin mode, ANV test, input. No, we're not using that. And then serial will begin there, and then we'll do screen. Clear buffer, set font, drawstring, delay. We're not taking in the delay. We're going to take the rest of this. Serial print line VN. Okay, so we don't need that. We'll just put all the screen stuff in there. And outputting WVFRMS. Is anything going to fit? I mean, the position is 010. What is the font? What's the, it doesn't seem, set font, U8G2 font, Ensign B08. Outputting waveform. How do I go to the next line? I guess we'll just leave it like that. I guess that's okay. And then waveform begin is called all up here, so that should start outputting everybody. DC1 amplitude, -1. We're not using. Begin sine, triangle, square, sawtooth, sawtooth, sine. So that's 6 channels. So get rid of this for now. And then that's it. We're not doing anything with the buttons. What up, Proteus? Oh, I already said hi to you. It's way past that time. That ship has sailed. Okay, yeah, that's it for a sample program. I mean, that's all it's going to take. Just 6 waveforms going out, I2S, and the screen doing something simultaneously. So now we can try to compile that and send it to the Arduino. And I know for a fact that the Arduino does not have enough power through USB to power the 3 of these. We've run into that problem before on the breadboard. So I need to get the power supply up here and move my man-baby RC car body. I should make a little platform for it. I can make a little disco platform for the RC car if I could minimize the, or make a base for this so that I could plug a microcontroller into it. And then we have a perfect little disco platform for the car to sit on. It's so stupid. I love it. All right, anyway. Let's see. I need to get the power supply, which is this. We're powering it off of USB-C because it's very easy to just buy a USB-C adapter that makes 15 volts, and 15 volts is the typical power requirement for Euro rack power. So let's upload our software. Let's compile and upload and find all of our semicolons that are missing. So that's just the one button. And we have, what? Access is denied. Oh, save as. This has to go to the desktop. The unfortunate thing is that I don't have permissions on this machine, and I really need to update it. I guess I'll have to save it elsewhere. It's putting a lot of stuff together, isn't it? There's a lot of stuff that's going together. To light the lights. Why don't you get this started? Compiling audio. Ugh. This is taking a long time. These libraries are vast. They're doing a lot of stuff, and this microcontroller is more than capable of handling it. I'm going to get a cord so that I can plug my scope in. A wire. Give me that wire. We can take a look at some of the waveforms that this thing is outputting. They're very clean. For these little chips are really good at doing audio output. Probably also do like sound, like actual music output. That's what they're built for. All this capability. What is this thing doing? It's still going. How much of the prog mem are you using up with this crap, man? Good God. Compiling core. Is that all? Jeez. This is... I guess the audio stuff linking everything together. Oh, there it is. And now you go ahead. I'll hit the reset button. There it is. That also took the upload. Took forever to compile. Outputting waveforms. This is all we get right now, okay? Jeez. And now, supposedly, there's going to be waveforms right there if I give this thing proper power. So I'm going to unplug that, and I'm going to plug in our power thing over here. I really need to make room for it. Hold on, let's push a couple things to the side here. I have somewhat of a space issue. A self-inflicted space issue. These are all the good stuff. These are the good chips over here. Oh, hey, it's the chip that I'm missing. Or maybe that's the one we blew up. I was looking for this. This little guy right here. This little headphone amp. These are expensive. I need to really make sure I keep this in a place where I can find it again. I was actually kind of distraught about losing that. Let's put it with the derelict chips here. And we'll remember that we put it there. I'm going to put this up above on the other side of Dick Butt so that it doesn't get disturbed by anything. I'd have to knock over the microscope to knock that little tray off. Okay, so Hello World gets plugged in. We can use either of the plugs, but I'm going to use the 10-pin. It's more standard. And now if I plug this thing into USB-C, we have right here, coming in from afar, the same power supply that's powering the scope has multiple USB outputs. There's a $75 laptop charger that got sent to me by accident from Amazon. Turn this off, plug in the power plug, turn it on. It negotiates for 15 volts, and nothing happens. Uh-oh. Why nothing happen? Who's getting warm? This thing should be providing everybody with 3 volts. Did I permanently blow something up? I don't think so. That thing's getting pretty warm. Unplug. Plug it in again. Hello, world? Nothing. All right. What has failed? Growing pains. Growing pains. Did I not connect the output of that to anything? That's happened before. It's time for a multimeter. Well, this is why we troubleshoot the hardware in the way that we do. We know that power is getting in from the 3-volt pin on the Arduino, but, and this may be something that I forgot to, I don't have my ADHD med, okay? Things will slip through the cracks. I think I didn't remember to connect the voltage regulator to everybody else. So if we put one probe on this leg right here, and we put the other one on VN, we get nothing. Good day to you, sir. Wait. We do get something, although it's 16 kiloohms. That should almost be directly connected. Now, hopefully we didn't give it 12 volts. That's coming in from here. No, we did not. Okay. I get many kiloohms this way, which is good. But over here, on this leg, or is this one as an output, is it? Oh yeah, this one's output. 400K. This is where 3 volts is being made. It's being output here. This is, wait a minute. Let's double check. This is an LM1117, right? Oh, what is this one? 317MG. Hopefully this thing isn't, what is that? It's like a surface mount. What is that one called? It's not really a TO220. It's like, yeah, D2 pack. Oh, no, no, no. No, no, no. You were a bad website. I didn't like you. Okay, 317M voltage. Oh, come on, Oki. Voltage regulator. Oh, it's adjustable? Oh, that's trouble. LM317M is an adjustable 3-terminal positive voltage regulator. The package is TO252. Applying more than 500 milliamps over an output range of 1.25 to 37 volts. We didn't give it anything. There's no device ground terminal. Quiescent current allows the load. Blah, 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 blah. Normally, no capacitors are needed unless the device is more than 6 inches from the input filter. All right. So what's my motivation here? Output is on the tab. Input is on the upper pin. So that's the one that should be going to 12 volts. And then the lower pin is ground or adjust. Let's check that. So this one, ground. That's correct. And then this one should go to positive 12. That's also correct. Okay, good. So this is what we got. This is what we got to deal with. I need to figure out how to get this thing to output 3.3 volts. It might mean severing ground from the thing. What's my equation? For maximum current, lowest temperature, 2.5 volt. Headroom is recommended from VI to VO. Okay, well, we definitely have that. Programming feedback, op amp with 125, blah, 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 et cetera, et cetera, et cetera. 1.25 volts squared over R. Oh, no, that's if, okay. All right, it might have a 3-volt example somewhere. Input voltage, up to 37. Output. Why is there so much stuff around this thing? This is ridiculous. VO is this simple equation. Vref times 1 plus R2 over R1 plus I adjust times R2. Why do they do this to you? Why don't they make these easy? Can you guys make it easy? Just give me an example of using this thing to make 3 volts instead of this godforsaken giant circuit that you're using. We don't get that. Our examples have 500 parts to them. Well, R1 and R2, R1 coming from our output, R2 going to ground. do? Input voltage range, design operation parameters. Can you just give me a greater than V6? Why does it do VREF? What is VREF? Capacitor, feedback resistors. Feedback resistors set to the output voltage using equation 2. VREF times 1 plus R2, R1. All right, what's VREF? Why are you keeping that information from me? V out is equal to VREF. Oh, God. Maybe I'll have to look it up. An LM317 is adjustable output voltage regulator. Yes. I have several of them in the TO3. I remember the configuration correctly if you need to apply a heatsink. Well, I've got a structure that'll cool it. LM317, 3.3 volts. That what? Why 2? Oh, there's a calculator. How to switch on and off voltage regulator. So 200 and 330 ohm. So let's get some resistors out, and we'll do the 200 and 330 ohm configuration like it's done here, and we can sever our ties to ground, at least from the one end. Yeah, LM317 is a little common. It's moderately common, but how are we going to do? Let's see. Ground is coming in from there, so I can just sever that. Of course, that ground is connected all the way through to that. So that pin has to somehow float. Ground. How did I do this? Power's going up to that one directly, and then ground is coming over to this pin. So I just have to avoid this pin and put a resistor on the ground lug. So we've got to kind of go around one of the pins here. This complicates things, but not incredibly. But it's perfectly good practice to use an adjustable voltage regulator that you're not constantly adjusting. That may be a feature of an adjustable voltage regulator, but 90% of the time they're going to be using an adjustable voltage regulator in a fixed scenario. It's fine. We're fine. So ground pin's right here. And so I need that pin here. Yeah, that's the one. That's right here. So we just need to, actually, it's very easy to do. Let me get power to the iron. So I just need to pull this right here, this one little piece of wire, which I believe goes a little bit beyond. And then we'll replace it with a resistor. And then I'll have to figure out the resistor to the output, which can be done on the top layer. All right, fine. You're just embedded in there. Don't tell nobody. And then I'm not going to use the solder sucker. Well, yes, I am. Let's get the solder off. Who's they? They is me. This is my circuit board. What are you talking about? I use the adjustable voltage regulator because I happen to have one. And I thought it was a fixed 3-volt regulator, but it's not. I got to order some LM1117s in the slightly larger package, the ones that go up to an amp. It's me. I did this. I didn't realize that it was an adjustable. What do we have coming through here? This is 12 volt. This is ground. And we need to go to the output. We're not going to 12 volts. So in this case, R1 is the one going to power. R2 is a 330 ohm to ground. So it just simply needs to go between this pin and this pin with a 330 ohm resistor. So let's grab a 330 ohm. That seems like a pretty low value. I guess the pin is probably high Z-ish. ish. I don't know why they wouldn't use kilo-ohms on this thing. It kind of makes a quick path for some damaging voltage to go through. $330. Tell me I've got that. 330, 0805. There we go. Perfect. Stick that one in there. 330. 330, and then I'm going to need a 220 as well. Sorry, 200. So I'm just going to get that out and put it on the desk. There. Go. Easy peasy, lemon squeezy. Well, this is why we troubleshoot. Okay, and then solder this thing in. Grab it, press it down, hold. Where's my heat? There it is. There's a lot of stuff connected to the ground here. 0805s are a nice size for the 0.1 inch spaced perforated prototyping board. They work quite well with everything else. The spacing. I prefer squares to the round ones because then you can use a variety of sizes of surface mount, but this will do just fine. Put like a status light on it. All right, now I'm holding heat there for a little bit because I want it to sink down and connect at the pin right here. The bottom pin right here. Looks like it is connected pretty well. Just double check that I'm connected on the right pin. I think so. I think it's that one. All right, so there's 330. Oh yeah, it looks like it flowed over. 330. Now we need 220 to the 3-volt output, which is here, I believe. So I could go out and around. I could go through there and then do a jumper. I could go from the adjust pin here to there and maybe jump through that. I don't know. Or I could go over here and come in this way, but that's ground right there. That's ground that travels across there. So if I put a resistor here, I could maybe, I need to get to 3 volts though. It's over here. So from adjust pin, resistor, and then over to 3 volts. So maybe we dot that right there and I just put it, well, that means it can go on either side. If it's going this way or that way, it doesn't matter. It needs to jump up and over to there. Ah. Wait, no, it just needs to go to output. So it can literally just go there and then I can do a solder jumper right here because that's what this is. No, that's input. Wait a minute. Oh yeah, output's on the tab, which is back here. All right. Let's see. If I drop a wire from here to here, I guess that'll do us. That's what I have to do. So I'm gonna get a little piece of yellow wire. I think I got scraps here. I got scraps all over the place. My scraps got scraps. I got so many scraps. This is a mess. This whole thing is a mess. But I guess it's my mess. And I love it. I'm gonna cut that a little short because I don't want all that excess wire. Basically, our heatsink is just all this crap. All that crap is gonna work as a heatsink. Drop this down conveniently right here. And then we can put the 220 just across the 2 holes. Curses. Oh no, this will work out. This will work, this will work, this will work. I just need to pull this thing up and then I need to apply a butt ton of heat. Actually, I don't really need that much, because I could just solder the end of this thing on. Yeah, wait a minute. We're doing this wrong. This needs to be super short. It's been cold outside, so that means that the other people that live here are pumping heat through the house, quite aggressively, I might add. And so it's actually quite uncomfortable down here in the basement. Quite uncomfortable. I have to open a window typically, but since it's so cold out, I can't open the window because then it'll be freezing in here. And I just need it to be moderately temperate so that I can survive. This is going to be tough to solder because this wire is going to melt. I'm using this super turbo, Tyco little baby soft play school solder to solder, or play school wire to solder this thing together. I wanted to have big play school wires just so that it was very clear what was going on the board. Are we going to add more solder to this? I guess so. So this is a big bucket of solder attached to this voltage regulator, but that's good because that'll soak up all the heat. Dang it, can't get wire in there, come on. That one. And now we put a 220 ohm resistor from the one with the wire sticking out of it to the one with the resistor. That 220. Get that 220 money. We just implant this one without going. Sorry, it's not 220, it's 200 ohm. We don't want to bridge to the wire next to it because that's 12 volts. It would be a disaster, as it would blow up my whole thing. Hey. All right, first of all, my hands are switched in position here. Let's flip the whole board so that I've got the right heat sources on the right side and the tweezers are on the right side, and then I can actually get in there and manipulate the position of this thing. And then we will have adjusted the regulator. And really, what I'm praying is that whatever we had there before didn't work so hard that nothing powered up. I hope it didn't pump 12 volts into everything. It might have. It might have really fucked things up. We will be lucky if the failure state is simply off, because I haven't tested this thing. So there's our adjustment done. I'm gonna add a little solder right there. Just make it a little bulbous. Little bulbous. There we go. This is probably gonna be. Oh no, that looks good. All right. So now we have our adjustment in place. We have the power going to the right spot and the output over here. Everybody should be hooked up. We didn't do any real big shenanigans. With any luck, everything still works. We're dealing with voltages that kind of break things. And I really hope this microcontroller comes up. Nothing else heated up. It was only the regulator that got warm. So, and this thing is still cooling off. Well, it's a testament to how much heat it's able to dissipate, how warm things have gotten over there. Please work. And then we have our scope hooked up. Well, let's get one thing at a time. Let's get this thing turned on, and text on the screen will tell us whether or not we blowed it up. I mean, we can test the functionality of the more sensitive parts by plugging in the USB thing. So let's just quickly test that. Oh, thank fucking God. that would have been more than $40 in technology if this thing had outputted a, like, these are $14 for 3 of them. This is probably another 10, and it's kind of special because it's yellow. And then this thing is like 40. The amps can take whatever I can throw at them, and the Donkey Kongs definitely don't explode. So it would have been between the screen and the micro and these 3 guys. It would be a big price tag for this thing to go tits up. All right, so let's give it the beans and potentially blow it up now. listen, I could be careful and take everything off of this. I could take all the technology off of it, and then I can test it in the most boring way possible. And that's the way you should do things. That's how you should do things. You should take all the technology off of this thing, plug it in, and of course, I have already ohmed out this board, but when you finish a job like this, you want to ohm it out first. You want to get your multimeter, you want to go to your power, and check all of your power twice. Just because stuff will get under the cracks. I had a little piece that I didn't solder together in jumper in order to get power to go out to the rest of the board. So this thing didn't work at first. You ohm it out first. You remove all the stuff that's going to make you cry if it blows up, and then you do some ohming and you make sure that everything's connected properly. I also had some power stuff that was flipped over here. I made assumptions. So, you know, the regulator not regulating, I know it's connected, but only the top of the screen is yellow. It's more weird than special. What are you talking about? The whole screen is yellow. It's got a little, you know, but it might be one of the ones where you can flip between yellow and blue. I'm not sure. My hands are falling asleep. That turkey chili really fucked me up, didn't it? Hold on. Well, my glucose levels aren't fucked. Look at that. For having eaten a meal, that's really good. Usually in the afternoon when I eat lunch, it just goes straight into the stratosphere. But this is doing really good. I need to call CVS and make sure that they've gotten my insulin prescription. I hope I don't need a prior auth for that. I've heard of them making diabetics, type 1 diabetics, go into weight loss programs to justify their insulin as if they had type 2 diabetes. That's scary, because it's like, hey, I need it to live. Can we just get me the insulin? Those would be some phone calls, I can assure you that much. But then do you have time? You know, you may have to go to the doctor and spend $400 on your insulin before they'll allow you to get it covered by the insurance that you're paying in order for them to cover you. Absolute bullshit. All right, so we're plugged into channel 2. My scope is actually, I'm actually gonna plug into channel 1. We'll flip it. Flip it. God, the scope gets very warm, and I should probably investigate the cooling fan and see if I can get a larger fan on it. I think I need to put a 120 millimeter fan on the back of this thing. I think that might be prudent. There is a cooling fan on it, and it is doing its best, but you can put a 120 millimeter fan on the back of this thing, and it cools it much better. And you can also put it in, you know, the low power mode, and it'll still move more air. I may go ahead and do that. I don't know. I'll have to find a fancy 120. If they start doing things like that, it's much too invasive into a person's personal life. Some people think being large is normal and want to be that way. What? I don't know. What do you mean? No, that's just like what they... Type 2 diabetics sometimes require insulin. And so what the health companies have done is require them to go into a weight loss program first and then get justified, you know, get the insurance to cover the insulin. But doing it to a type 1 diabetic does not make insulin. And so insulin is required to just function. Even if you're fasting, you need insulin in your body. It's a required hormone. And it's part of the system that regulates how much sugar is in the blood and the transport of that sugar into fat. But having that kind of thing apply to a type 1 is criminal. Because a type 1, I will, you know, skinny or fat, I will die without insulin. So would you. Insulin is luckily covered in German healthcare. Yeah, you know, most, all but one of the first world societies have managed to cover things like this just fine. All but one. Why? Why? I really, like, I don't know, at some point I'm gonna have to stay on Gonad's couch just to cross the pond and actually get covered. It hasn't quite come to that yet. Not yet. I'm very reticent. I'm very worried. So I'm trying not to, I'm not going to talk about all of my worry about that, but I don't know. At some point I'm going to end up couch surfing with y'all, all my internationals. All right, ready? 3, 2, 1, power. Yay. Okay, power off immediately because I don't trust that. Yeah, nothing doing. All right, so we got to check what's going on. What is your typical A1C? Mine's in the 7s, but that's personal information. I don't really need to share that with you guys. I'm very open about my diabetes with you guys, but let it be known that it is very rude to walk up to somebody on the street and ask them what their A1C is. That is a no-go. R2, 330, connected to ground, check. R1, 200, connected to output, very check. I think this is a broken regulator. Oh. What are bobble? What are bobble in middle of chip? What's going on right here? Is that an oopsie? I don't know if I have another LM317. Well, I got type 2 due to age, not weight. You can also get it from pregnancy. Yeah, it's like we get kind of browbeaten about our A1C, and it's kind of a personal health question. I got type 2 age limit. Didn't think it would consider personal, especially with all the discussions. Yeah, no, don't let me be the norm. I'm not the norm. I'm not the norm. I am very open about diabetes. You don't have to be. It's a medical condition. It's your own personal business. It's very personal. It affects every facet of my life. I talk about it openly here. I make it a point to be extra open about it. If you meet diabetics in your life, they don't have to be that open. They have no obligation to you to be open about their condition. I happen to be very open about it. Just know that about me. And you know, politeness. There's things you know that are polite and impolite about discussing diabetes. I am super. You know, we talk about farting and pooping and fucking all the time. Like, I'm super lowbrow when it comes to that kind of stuff. But you know, higher brow people may hold themselves to an alternative standard than what I do. Yeah, people are always giving diabetics advice. You should try okra. All right, we're looking for a... How many of these do I have? Holy shit. Low voltage sensor. When have I ever used a low voltage sensor? Why do I have like a whole... Jeez. 2.5 volt reference. Those are references. Power reset. Temperature sensor. Accelerometers. Magnetic field sensor. These things are neat. Crystals. SMD crystals? Nah, none of that. Here we go. Low dropout. LDO regulators. 1 amp, 3.3 volt. Oh god, this thing is cursed. Do I have anything that's in the shunt amplifier? Neat. Shunt resistor. 3 to 5 volt LDO. Those are cursed. 1 amp, 2.5 volt regulator. These are just holdovers from something. Well, yeah, and like a lot of the discussion around weight loss I don't really agree with. And maybe it is a personal opinion, but I just, you know, the whole calorie in, calorie out, you have no excuses, fatso. I hate that attitude so fucking much. It just really bugs me. And it's a thing that my thin friends for some reason have all taken on. It's, oh, you just don't eat. You just don't eat in and you'll be fine. It's like, bro, I have like the worst hormones in the world. Like, my shit's all fucked up. Like, there's more to it than that. So easy to just boil everything down into an equation. It doesn't, yeah, it doesn't really need to be in a particular package style. We'll just redo that whole area. So this thing does 3 volts. What are the markings on it? I'm going to have to just blow away that whole area and reinvent it, which is fine. It depends on what the pinout of this thing is. 85AB. So we're totally reinventing that area. Oops, that doesn't give us any information. man. Oh, nice shot, man. What the hell? Very low dropout voltage regulator. That sounds like my style. It's not. It's not my style. None of these are my style. This is a mistake. This is all a big mistake. Oh God, what have I done? What the hell? I don't even know what that package is going to be. It's going to be quite a bit of... I'm not familiar with that voltage regulator package type. That large tongue is one. It's like TO2 something 20. It doesn't... Listen, the package type will be important for finding that we have the right thing. And then we need the data sheet from it to look up. But this is fairly common. It's just got 4 tabs. But the one big heatsink tab, I mean, this is sort of normal for surface mount voltage regulators. There's a bunch of cursed package types, and so we need to be able to navigate them all. We're never going to be familiar with exactly, oh God, what I have. Sorry, turkey chili is doing a number on me. 8-channel EMI. Actually, wait, didn't I identify what? I have the part number on the case. What am I doing? What am I doing? What kind of a shit show is this? All right, we're it's an SOT223. That seems not like SOT223. LP3869. Nice. LP3869. Nice. 3869. Voltage regulator. LP38 blah 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 blah. The LP blah, 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 low dropout CMOS linear regulator to provide tight, tight output tolerance, extremely low dropout voltage, and excellent AC performance using ultra low. It's all one word, probably because they copyright it. Equivalent series ESR ceramic output capacitors, low thermal resistance. Blah, blah, blah. Okay, whatever. 1 microfarad on the in and the out. Input and enable, or is enable tied to anything? Or do we just leave it floating? I think we can just float it. EN. Yes, I know that it's there. Next. Oh my God, it's on like every page 5,000 times. All right, close this. Let's just get down to the application circuits. Application circuit. Which one is us? That's us right there. So enable and NC. Okay, so those, well then. Okay, so those don't do nothing. V out is on this pin. Okay, so that easy enough, right? C in and C out are 1 microfarad, and I probably have the right stuff. Hey, what's up, Commander Kellogg's? Hey, Disco House Days, how you doing? We just had all the insulation in the house replaced after we had a rat. We had a rat in the house, and it ate all kinds of ridiculous stuff. A lot of traumatizing going on around here for the way that the people that I live with carry themselves. They're very clean people. So having a rat is seen as an indictment of our own housekeeping skills. But we just had all of the insulation replaced, and everything has been cleaned, and now we are back to square one with this whole thing. So what an ordeal. Okay, so we need to rip up this entire area of the circuit, and we will be replacing our voltage regulator that's in there now with a 3-volt 1 amp. There's a milliamps for this circuit. I know that these are a little bit hungry. They require a little bit more punch. I'm updating my setup, decided to grab a new 1000R curved monitor and dual monitor arm. Turns out my current monitor cannot be mounted, so now I need another curved monitor. Oh man, that is a setup. I didn't do curved monitors. I know Flatulent. Oh, that's Willow Cam. Flatulent Gonad did the curved monitor. I don't know. People see them as totally like solving a problem that never existed, but having like an ultra wide is crazy to me. There's an Easter egg in My Summer Car. I don't know if you've ever played My Summer Car. It's an excellent game about trying to survive in Finland. Feels a lot like New Hampshire. New Hampshire and Maine. Feels a lot like surviving in those places as well, mainly because, I don't know, a lot of Finnish people, didn't they immigrate over there? And it's like the same environment. They're like, ah, yes, this is good. This is our original environment. Very good. Feet of snow. I'm just at home. But anyway, so that game is amazing. But apparently there's an Easter egg on the title screen. There's a character sitting so far off to the side that you have to have an ultra wide in order to see it. I thought that was a very cute thing. Ultra wides are crazy because you'll be driving and you think you're going slow until you realize what a regular monitor views. Everything looks like it's going super fast. So you have this awareness of your driving that you wouldn't have with something other than a curved monitor. This has been described to me by Flatulent Gonad. I have not experienced that myself. Okay, so we're ripping up this area. We're doing a little laser robot missile surgery. So let's go over here. Let's get all my tools, get my tweezers, and then we go to this, and then I get this thing out of here. I guess we blew this up in another circuit, and that's why there's a little mark right here. I don't know why I kept it around. It looked like it was new, or I just blew it up right now. I'm gonna get this capacitor out of here too. This capacitor is kind of cramping my style. And I'm gonna unrecoverably remove the capacitor. So I'm basically just bending it until it capitulates. Did I just get a ton of heat from something, or was it? I thought I felt something really warm. No, there's no heat on the board. That was weird. That was my sense of touch getting confused by my sense of temperature. So I just had to buy a new monitor. I had to just buy a new monitor. It's still in the box behind me. My monitor didn't want to take any of my BS anymore. It died from me literally standing up. What's that? A big earthquake off of California? Huh. Well, it's big news, but it doesn't affect me here on the East Coast. I hope everybody's okay. Don't stand up like that. Okay, the chair is one of these steel case chairs, right? It's ergonomic because I'm a big fat guy. I don't want to have spine problems. But I stand up, and apparently, I guess part of my butt rubs against the fabric of the chair, and there's no static mitigation on the chair. So the sparks are jumping from fabric to fabric area, I guess. And it could have to do actually with the piston expanding as well, creating big static electricity. But so when my butt leaves that chair, it creates big static shocks, and those big static shocks have a huge RF component to it, which gets absorbed by potentially a big piece of sheet metal behind the monitor. And then that sheet metal discharges it down the power cable to the power cable that's shared by the PC. So what'll happen is I'll get up, my monitors will go blank, and then my computer will restart. And sometimes when it restarts, it does not recognize the AMD drivers. So I have to fully reinstall the AMD drivers so it doesn't have generic monitor. And that finally happened for the last time, because when you static shock chips and they're affected by the static, there's a statistical probability number of times where the static is able to be transferred from the gold bonding wires to whatever circuit path they get to on the silicon chip. The problem is those gold bonded wires are held down by a cold weld, and cold welds are used quite a bit in electronics. But that cold weld is just two pieces of metal. It's a piece of gold and a piece of, well, no, it's just a piece of gold being deposited onto a semiconductor. When that static blasts through, it removes a little bit of the material. Oh God, that just came right off. Oh God, this thing was in worse shape than I thought. It just blew up. But yeah, so that happened, and I guess something finally fully disconnected for the last time. And so my monitor is dead, and I had to order another one. Hopefully ViewSonic, I don't know why I bought another ViewSonic, but hopefully ViewSonic will do something to mitigate that static charge in the future. That's why you have all of these big, yeah, I know, like immediately just went, okay, I'm dead. You got me. I'm dead. I'm super dead. Hopefully they will have done something to mitigate static, but with static electricity, there are devices that'll dump it to ground, and then you have like a big ground plane that sort of permeates your entire design, and it allows for those circuit paths to take up, to be the lowest resistance thing, and then be utilized by the static electricity. That still doesn't mean that static won't go through your electronics, because electricity doesn't take the shortest circuit path, it takes every circuit path. And so if it's able to jump gaps, it's going to take every circuit path. And so you want to make sure that a very small amount is left over to take every circuit path. Flat pads, I got to use solder braid. This is very wasteful. But then for these holes over here, I can use the solder sucker, which is cheaper because it's reusable. I have an MSI monitor, and for 2 years, I've had to look at a tiny dead ant I squished, turned out to be behind the screen. Holy shit. Every time I've tried to do an operation with like a screen, especially on the Goop 3D printer, where you have to like put on a screen protector, right? It's a good idea to put a screen protector on your Goop printer because that shit gets everywhere sometimes. And if it gets everywhere, you don't want it directly down on the glass of your screen. So I put a screen protector down there, which has saved me more than a couple times. The problem is whenever I have to apply something like that, I don't know if it's just my natural environment is just full of particles all the time, but I always struggle to get it clean. And you see people doing it in videos and they do it like perfectly. They're just like, boop, boop, okay, we're done. It's like, what is up with you? How do you do that? The problem is this form factor of the voltage regulator is different. And so it's going to be sort of annoying for me to get running. I just don't get how they do it. There's always a little speck of like white dust that'll just get on the screen. It drives me crazy. What's going on up here? Oh, right. So that's where we connect to the main pathways. And I guess we do it for this. What's that doing right there? Oh, that's the pin that we removed by force. How am I gonna make this work? That's 12 volts coming out of there. Probably should have put everything to wires. If I put everything to wires and didn't do this cute little way of routing traces under the board, I think I probably would have a better time with this, since I could just throw down a different package in this area. But I don't want to convert it now because I'm lazy. So we can make 4 pins work in here. Input is from the far left pin. Okay, so that'll make it easy. Looks like in San Francisco or somewhere around, there's a lot of small cities. They're having the cops go in, warn the public to head for the hill. Oh, crazy. So there's going to be like a huge tsunami. Okay, so this pin here is our input pin. So that can actually go there. And then I can put a piece of Kapton tape down. Enable and no connector there. Out is right here. And then this one is ground. Ground is here. No, ground is here. What's this one? This is ground coming up. Or is this power coming up? This one's ground. So that one can get connected if this is where power takes a turn, or is this where ground takes a turn? I don't know. Hold on, let's ohm it out. I don't want to bring the multimeter into this. Let's just take a look at this row. I don't think L corresponds to L on this side, does it? No. Why would they make them correspond from side to side? Why would they be labeled the same? Why would you label anything similar to the way it's already labeled? Like L over here, not being L over here. What is their goddamn problem? Okay. You know, why bother? Why bother? I'm trying to put it in this area. No, it's like K. It's not labeled the same thing. God damn. This one right here. I wish I could see through this board. It's one of these. Like, does that one have that one? I think is under the. Oh, yeah, I removed that. All right, so yeah, let's get some of this stuff out of here. What do we have? We've got 2 things there. This, I think, doesn't go to anything now. It just goes to this spot. That could easily be output. This is ground coming in here and connecting to the rest of ground. And so I think that one is empty because I took the capacitor out of there. Yeah, I did. Now what's unnecessary here? I think this one is unnecessary. That one was also a capacitor lead. Yeah. Oh, that looked like it looked like there was a big hole there. Weird. It's very clean looking. So that one is positive 12 coming from up here. That one connects to positive 12. And so that'll go to the in pin, the in pin. This one is output, and it doesn't need to be that long. But so doing it from this side, it's in and out are the two pins on the right-hand side of this thing, and the other two I don't need to do anything with. So if, I guess I can't really do that here. No, that doesn't seem to be very available. Just because of the way this thing is. Because it'd be like it is. If I did it like this, input could go there, but ground I can't reroute. Ground just has to go in that direction. Like float it. No, I'm not going to do that. So I guess if I put all the pins here, I can get to everybody except for output. And output I can just jump over. Those who are right there have a new kind of fear. That one's actually no connect, so I could actually put this thing like this, and then output shares no connect, and it's got a nice double thing. And then enable just floats, and input is down here, output is right there. Okay, yeah, I think that's the plan, and I'll have to run jumpers. So input and then output will get a jumper from down here to up here. This is ground. Can I, actually. Well, then enable goes to ground, and I can't quite do that. Yeah, that doesn't work. Okay. So we'll just have to float it right there. And then I don't need to use like Captain tape or anything like that. So we'll put it right there. Put her there. And then I'll do jumpers for everything else. What about this? This one and this one are not needed. Although, yeah, well, no, ground is coming up and does its weird maneuver. So yeah. This way. We'll just do it this way. This is the make it work section where I make it work. I don't take no crap from no one. I make it work. All right. It's a little crooked, but I'm willing to accept that for such a DIY effort that we're doing here. That's why I say, hey man, nice shot. What a good shot, man. And that's the heat sink. That's why I put an excessive amount of solder on it. If it gets too hot, which it's not going to, I guess I could probably put a piece of desoldering braid up at the top. Actually, we have a bunch, don't we? We just wasted all of that desoldering braid, so I might as well just place a piece across, and that'll help bridge us to the output. So I'll just take this here. What's going on with the mouse? I just hovered over a bunch of stuff when I moved my hands. So I'll take the piece of desoldering braid that we used earlier and just slap that sucker right on top of it. And that'll make us a nice big heat sink for our regulator, even though it's not really going to need it. Nice shot, man. I just have a song in my head. Just a song, nothing more. I could bend these up and make it a cute little heat dissipator, but I don't really. We don't need to get that fancy. I just need this to lay flat on the board and connect all of these edge pins. And that creates a nice copper heatsink for us. That should dissipate more than enough heat. To be fair, we barely need anything on this. Okay, so we're still not hooked up to anything. This one, we need to get over to there. What's the other one? The other one's output. This is output. This needs to go here. So I still need a jumper. And I guess what I'll do is I'll cut this right here. And what am I doing? Let's see. This one here we should remove. Even though I think there's stuff in it. That's where the capacitor was. Look where my hand was. I'll reduce these to 1 pin. And then output here, I guess I'm going to find a jumper to go from here to here. And then we'll do, this is a mess. This should go here. This needs to just go over 1 pin because that's where 12 volts is coming in. So let's get a small jumper for our input. There's no wire in that. That's only a jacket. I've been doing this for a while. Look at a little piece of a resistor. How about that? Well, you have no choice in the matter, but I figured I'd ask anyway. What a week so far. If that earthquake thing is real, not to question the authenticity of my chatters. It's just news spreads fast, and I don't like jumping to conclusions too quickly here. We're not really, we're not a political show or anything, and I know earthquakes aren't political, but they are just something that, like, is that real? Is that happening? I need to check my sources. Yeah, I'm not soldering a coin down. That is a legitimate method. Soldering down a coin. It's a legitimate strategy. Silly enough to connect it on the other layer, but that's there. Ground is going to the pins next to it, and then this one needs to be enshortified. Because that's our output, and we're going to need that pin clear for a jumper. So I'm going to cut this close, not too short. Did that on the TP-Link routers, using a coin as a heatsink. That is fairly ghetto, but it is, I mean, copper's copper. Well, metal is metal, I guess. It's not necessary, it's not copper. I don't think they use copper on the coins anymore, right? Does it solder well? I've never tried. That's defacing American currency, and that's a felony. You just admitted to a felony live on my chat. I'm calling the police. You felonious bastard. All right, power is connected. We need to get a jumper from here to here. That is very annoying, but it's doable. I need to remove the solder from those pins. I thought I'd have more space. You can't get heatsinks that cheap and that size. That's true. Could I cool a modern computer by soldering a bunch of pennies and putting a fan on them? There's a challenge. There's a maker's challenge for you. Cool my computer with pennies and a Noctua. And a Hawk-Tua. No, everyone's already made that joke. Everybody's already made that joke. I don't need to make that joke. Really? Yeah, I've bought copper shims before. That's where I would be thinking. Rather than defacing Uncle Sam like some kind of an asshole. How dare you? This is my country. My damn country. The Mon Bazo song. This is my country, my damn country. This is my country. It's patriotic. All right, so there's our output, which, boy, is that in a weird spot. Oh, did I just melt the crap out of that? No, I don't think I did. I might have touched it a little bit. Send you a handful of euro cents so I can deface other countries' currency in an act of what could be assumed to be a declaration of war. Now, the only euros I would want you to send would help me abscond away to another country that has health care. Because we're not allowed to have nice things. A little bit of excess solder on that. It is sloppy in this area, but I guess it'll do. No, don't you put those British coins together like fucking Exodius? And you've got like the full queen, and you've got the power of the queen, and you can cast like Brit magic. Oh, that's right. They changed out all the currency, right? All the new currency, I guess. I don't know if they changed old currency. He's got like 45 minutes in him to be king, right? Looking like a Fallout character. Yeah, it's going to be a process. Interesting. It's a whole thing, and we're all involved. Okay, so without the capacitors, we still need to connect this to ground, so I just need to go just a little jump from this run over here to the tap. And I guess I'll use that resistor that I was using earlier as kind of a sacrificial wire provider, wire cutter pliers. There's a line in an Aesop Rock song, and it's just wire cutter pliers. And I'm like, how did you rhyme wire cutter pliers? How did you do that? What the hell? And so it just kind of stuck with me. How did you make that sound cool? I don't understand. Okay, that grounds us. We are grounded. We have ground. Not the most elegant install I've ever done, but our voltage regulator, our voltage regulator is connected. I was hitting the wrong buttons. I meant for this one, but instead I got all the overlays. I got my pee pee poo poo overlay and stuff. That one animates really fast, which is funny. Specific warnings to specific areas for a tsunami. It seems like they have an idea of where it might land. We've got a lot of microphones under the sea. Do those detect tsunamis? I don't know. We have a lot of very advanced technology for that kind of thing, especially in the Pacific. The specific. All right, here's the deal. I'm actually going to be nice to myself and not waste hundreds of dollars of electronics. Well, tens, almost $100 in electronics. So I'm going to very carefully remove these things. Got to be careful on this one. These flat pins are very low profile, but they also are very difficult to remove. And if you do it wrong, you can bend everything. Ooh, ooh, ooh. Now I bent it a little bit. I'm not worried about the 12-volt regulators. Those won't, or the 12-volt electronics. Those won't. Those will take it in stride. And then I need the multimeter to test voltage. This has been a struggle. We've had kind of a struggle here to get this thing up and running. But I like to show the process, and this kind of stuff is what I excel at. I love doing it. I could do this all day. And I just might. All right, so voltage, and then we've got our power cable here, and that is on metered power, so if it's using a lot of current, we'll know. Put that there, turn it on. Look for these to move at all. Nobody's moving, that's a good sign. Our voltage regulator is heating up a little bit. It's not really going to be providing anything with significant power, but then we go to here, and we go to here, and we see that it is at nothing. 0.79 volts. How is it heating up? Is it heating up a lot? No. No heat, but something ain't doing. So let's just double check that we've got between this pin and the input here, 0.5 volt. How about from here to here? That is full 12 volts. That's why it went into overload. So that's full 12 volts. So we're not putting power onto the power pin. Onto the input pin. The in pin. The in pin. In. Well, how is that possible? Oh, maybe the other side didn't solder. This is my solder. My damn solder. What's that? That's grounded. They're grounded. They're connected to ground. I must have missed the explanation, but how come we're dismantling the circuit board? The voltage regulator was a dead regulator. I thought it was a new one, and maybe it was, but we killed it. We either killed it or it was already dead. So instead, I am now replacing the voltage regulator with another one that I had, because I don't have another one in that same form factor. And it's messy. The voltage regulators that I have are very varied. There's a lot of variation in them. And I've got all kinds of different weird packages from, you know, like the Spark Fun grab bag kind of thing. So I'm using one that I just happen to have that's 3 volts at 1 amp. And it's a different form factor, so we are tasked with making it work, which I've done. It's a little sloppy. We're using a no connect pin on the input there, or on the output, sorry. On the output there is also connected to an NC. Should be fine. Ground comes in through the tab, and so accessing the tab, we've given it a huge heatsink made out of old solder braid. Solder braid's good to have around. It's expensive to get that much copper to do just, you know, any old desoldering job. So when there's an opportunity to use it for something else, like a big current trace or a heatsink, it's nice to have it to use. So we were able to use the whole Buffalo, nose to tail circuit bending. I have plus 12 coming in here and doing a little jumpity jump right over there to the pin. So now I get to test to see whether or not I actually get very low ohms between the 2 points, just to make sure that we are connected to power. So from here, we go all the way to the leg itself on the regulator. Oh, that's volts. Ohms. 11K, what the heck? Where are you getting kilo ohms? What's happening here? 63K. What's happening? Wait a minute. What is going on here? Did it not solder down, or do I not have that last jump? Oh, that's a little sloppy. We're all the way over here, and we're on the output pins. Oh, I wasn't measuring it to the out. That's right. This trace is actually this here, which is definitely connected. It's from this pin to this trace where we will have 12 volts, and that's ohms. It's 0.3 ohms. Okay, cool. So now we're ready to go. We're ready for the power test. So I'm gonna go over to volts. We'll go over to here, bring you guys in a little bit. And now I can plug in the power plug. This is how we should do it, with everything disconnected and the highest possible margin of safety. Power on. That's gonna get warm. And then we check to see between ground and this pin, we should have 3v3. We get nothing. Good day to you, sir. 3.6, 3.7, 3.8. 4 volts is kind of the upper limit to something like this. And the regulator's not powering anything right now. So it should drop down as it powers stuff. 3.8 is a little bit sloppy, but I think with load on there, it'll lower. Or we may need a capacitor. Turn that off. Everybody back in the boat. Let's disconnect this. Go. Where did my monitoring thing go? Coming back over to here. All right, so this thing plugs back in, and unfortunately, I have to kind of roll it. I have to kind of roll it back in because of the way it came out. Things won't align properly with these. Actually, we're still in the margin of error for this, but just because, yeah, no, it looks like it's not going to press in because these are slightly bent outward because I pulled it out like that. That's a mistake. I should have used the tool to pop it upwards. Don't be like me. Do things properly. There you go. All right, that's in. This one has to be 2 from the edge, otherwise I blow it up. I haven't blown this one up, but, you know, 2 from the edge or I blow it up. It'd be nice to have standoffs for this, but they're right in an area where there's a bunch of wiring, so I'm not going to do that. And then here are the audio drivers. These are I2S audio drivers. They're nice. I mean, $14 for 3 of these things. They don't have... I will never understand with these freaking manufacturers why they don't align these to 0.1 inch spacing, because they're not. They're off by just a little bit. I don't know what they expect people to have, or what the common application of this chip is. Maybe it has some other application outside of what I'm doing. People making their own MP3 players and stuff. Remember when MP3 players were a thing? Okay, now, with any luck, I flip this switch, and this thing says outputting waveforms. Here we go. 3, 2, 1. Bonk. Outputting waveform. All right. How warm is this thing getting? Oh my God, it's on fire. Why is it on fire? It's just warm to the touch. It's kind of cold in the shop right now. This thing is probably doing a couple hundred milliamps. Oh yeah, there we go. It's almost doing 200 milliamps out of 12 volts. This one is unfortunately never really going to be used at all, because we don't test modules that use 5 volts. It's really these two where all the action's going to happen. And this one should probably be a 1 milliamp, because yeah, here we're pinning at about 120, 150 actually milliamps. It's a lot of current for this thing to be drawing. But now we can see whether or not we have waveforms. Bonk. There we go. And let's get the cable. Oh my God, it's such a mess. That's not the right one. This thing is getting quite toasty. I hope it doesn't keep getting hotter. Ow! Okay, this thing is getting very hot. We are using a lot of current, it seems. And we are not outputting waveforms. Okay, cool. Wait, what are we set to here? 6 volts? Reset. I'm still outputting waveforms. Either, well, could something be shorted, or is it just using a lot of current? I think it's just using a lot of current. It's possible that these aren't adjusted at all, but we should be seeing something out of them. I know I'm sending them power, and I know they're connected the way we had them on the breadboard. So really, by all means, we should be outputting something, but this is erroneous. Whoa. Okay, apparently that drops out when I touch certain things on the board. Yeah, these modules use a lot of current. I'm looking at the arrow over here drop down when I remove one. Watch. Bonk. Drops a little bit. And it drops a little bit more. So this is what the microcontroller is using. So let's take a look at our signals coming in. So to do that, take a look at, there's this probe right here. We need a ground. So get one of, where did that thing go? Well, this is how we were connecting to ground before, but I don't have that option. I would like to find a little blue wire that I had over here, and it was one of these ones with the DuPont connector on the other end, the pin connector. because I can drop that onto this header right here. But it's gone forever. Gone forever. Nowhere to be found. I'm just out here hoping and praying that I find my jumper. Where'd it go? Oh, there it is. Yeah, you're right. Upper left corner. Nice. Yeah, I don't know. I don't think it's dropping out, actually, to be honest. Because this stuff is still powered just fine. It's a little jumpy, but it is still powered just fine. We can see. Let's take a look. So we should be somewhere below 5 volts on this. Yeah, so that's stable there. And we can see it's 3.39. So 3.4 volts. Once you give it a little bit of a load, it kind of regulates itself. And this is cooling off a little bit too, I think. I can't believe we were up in the 150 milliamp range. So ground here, and then V in here. That's just fine. V in here, that's just fine. V in here, that's just fine. Digital signal, yep. Other digital signal. What? No, what is that one? Oh, that's the unused one. Actually, that's where serial clock comes in. Wait a second. Did I not hook it up to anything? SCK and then BCK. Oh no, it doesn't need an SCK because it'll regulate itself. Yeah, it gets B clock, then D in, and left and right. Ground and V in. So we're not using that top pin, and then our output is on the other side. Well, we don't see the outputs unless one of these is plugged in. It seems like they're getting all their proper signals though. That one is B clock. Let's see, B clock, B clock, B clock. It seems a little less enthusiastic than the others. And then D in. What is this? B clock and then D in. D in is a wave. D in. Why is it on channel 1? What the heck? Oh, uh-oh. Did we just kill the board? No. I'm gonna hit restart on it. This one is not getting D in. Oh, nor is this one. Wait a minute. We may have lost signals. Oh, did I just kill it? I may have just killed something. I don't understand what you do or say, but I love your streams. Keep up the good work. Thank you. I think I might have just killed my Arduino by dropping this thing on it. I dropped this ground wire directly on this, and I think it might have killed it. We're going to turn it off and on again, and it's probably not going to come back. Because the screen's probably just working off of an old I2C message. No, that's back. Okay, all right, that's progress. But we get, oh good, we do get a serial clock? No, that's a floating pin. There's something. And then next to that, okay, and then next to that, that's our LR clock. Okay, so that's getting full. I watch paleontologists on Twitch. I understand nothing but bones and skulls, but this is fascinating. I appreciate you guys being here. I know this is like troubleshooting, so this is less to do with the actual operation of electronics or the basically in troubleshooting. What I'm doing is I'm checking power, ground, signal. That's it. I just want to make sure that it gets everywhere, and soldering errors that I kind of know of and have experienced in the past. But mostly this has very little to do with electronics and more to do with troubleshooting of technology. So if you know IT, if you know a little bit about computers, if you know how to wire a light switch or put together like a bathtub, this is very much akin to that. Is something leaking? Is something getting in? Is something not coming in? I'm fascinated of what he does, but it's way out of my league. I try to make it as accessible as possible. I know that stuff goes over your heads. You guys can ask questions. I may be snippy when I answer if I'm in a bad mood. I try not to be like that. It leaks in from just all the personalities that you you experience on Twitch. But I think it's wonderful that you guys enjoy watching something that's over your head. I have, you know, many times in college, you enter a room and there's like two professors talking about something that has to do with like biology. Everything is above your head. It's good not to be the smartest person in the room, because all those other people around you elevate you. And I hope that by coming in here and being at least just exposed to somebody talking, somebody who knows how to talk about this kind of stuff that I know how to do, I hope it elevates you. I hope it gives you at least something to take away from that experience. But thank you. I really appreciate those comments. You guys are very nice and tolerant. You guys are tolerant of my bullshit. All right, I'm gonna turn it off, and then we're gonna look at the audio output. So we know that we are getting digital signals all the way into the units. As far as those digital signals look, they look kind of like actual signals. I love learning new stuff, but this is not the basics. Yeah, so if you want more basics, I mean, even like Uo's lab, he does a lot of very basic science and engineering kind of stuff. And when he does stuff with like microcontrollers, he's on kind of a different level. He does a much more simplistic stuff with them. He might be a better place to learn, although his show is about as irreverent as they get. For us, I try to not shy away from the complicated, from the really, truly weird and tough things that you can engineer with this kind of stuff. Because the difference between Uo's lab and my show is just slightly different ideas of the application and the amount of work. That's it. You know, it's like, it's not magical to jump up to this level. All I've done here is connect a couple audio output things to op-amp circuits. That's it. That's all I've done. This is as simplistic as electronics projects get. This is a 101 level of electronics to get to here. It's just the journey up to this level is what's kind of daunting if you just drop in on this now. We've been working on this circuit for some time. I had the whole thing built over here on the breadboard, and then this is just part of the module testing module. I decided to make it into its own little module for the time being, because the big project took a lot of time. It's going to take a lot of time for me to learn. I do have some experience with electronics, but nothing in depth. I mostly compared what I've seen and made sense of it. You know, eventually that turns into electronics skill. You just have to apply yourself to the numbers a little bit sometimes. It eventually all bleeds into the right stuff. All right, let's power it up again. And now this regulator is going to get pretty toasty. I'm a little worried about this regulator being sort of over. I don't know why these things take up so much current. Oh my God, there's somebody at the door. I'm a little worried about these, the voltage regulator not being able to provide. It can do, I think, 500 milliamps. Why is there no output? All right, so did something programmingly go wrong? Is the programmerly stuff wrong? Because these should have about 6 volt peak to peak. So they should be very visible on this scale. Or did I hook up something that ain't supposed to be hooked up? So I'm just tapping into these lines just to see if there's any signal here. Now the op amps that are under these should be running. Well, they should be tuned already, assuming that I've hooked them up right, but they're high Z. So that high Z should not be affecting the output from those pins. It seems like everything else is okay. We're just not getting the output. So is it a programming issue? Turn this off just to save heat. Is the time scale right? Yeah, time scale's right. We've got digital and audio signals, but they're all visible around the same time scale. Audio memory 20, waveform begin. A and V tests we're not even doing. We don't need serial. Now we see the digital signal coming out of those though. Clear buffer, set font, drawstring, send buffer. That's what's going normally, but we've already set these to output those waveforms. I think our code is fine. There's not much to it. There's some excess stuff in the code, but this is what we had running before. 3, 4, 5, DC1, waveform 1. But then we're not getting anything out of these. So is there some other thing to the output that I'm not doing? What if I pluck this one upwards and don't connect those pins? And then I can see what's on the outputs here. Nothing. There's a waveform. It's a triangle. When I plug this in, it goes away completely. Nope, it's still there. One of y'all's a triangle. Might be that one. This is going to the bottom two here. So this should be a triangle. And it should be a 10-volt triangle, but I think it's on the wrong tune. Let's get a tiny little screwdriver and adjust it. No, I don't even know if I'm on the right one. I probably should be. The lower one goes to the right-hand channel. Actually, it might be this one. Oh, no, yeah, the red wire. Okay, yeah, so this is the upper one. I don't like the amount of current that these things are taking, but I guess that's just what they do. Try a different tiny screwdriver. This one has a wider blade. It doesn't exactly fit into the little thing here. I really should make an adjusting tool. Ugh, I hate these things. The flathead screwdrivers on these things are very annoying. Going right. These are 25 turns, so it takes a little bit to adjust. And left. Nothing. Nothing. What's wrong with my circuits? Check over here. So why? It may be capacitors. Maybe the reason why these don't work. There's a waveform in there. What about here? It's just not a very high amplitude one, is it? And it should be 6 volts peak to peak. To be fair. So yeah, this is major troubleshooting that we're doing right now. Even serial clock has more amplitude than our signal. Look at that. Wait, that shouldn't be that far outside. Ugh. What's our voltage doing? 3 volts, 3.2. So what are my amplifiers doing to everybody? They're very simple circuit layouts. Should be a very quiet signal right there. Whoa! Oh, that's a feedback. Huh. Well, I see. No, I actually don't see. I have absolutely no idea what the hell's going on here. Dun, 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 dun. Check voltage going into these guys. We've got V in is at 3 volts. Hold on a minute. V in here. 3.2. Yeah, these are well within their operating parameters. So my op-amp circuit, that thing is hot. Damn it. That voltage regulator does not like this thing. I probably need to look into a much higher, well, a better heat thing. I have weird heat sinks all over the place. I just don't want to, use them for something like this. This doesn't require a big big voltage regulator. The screen works perfectly fine. The buttons I haven't programmed yet. And it appears that our audio drivers are working just fine. So let's check over our op-amp circuits to make sure that they're doing the right thing. So I'm going to power down everybody, and then remove this, and then almost burn myself on the voltage regulator because my finger was touching it. Jeez, why do you get so warm? I need to... Can you not do two parallel regulators? That's not advisable. No, sometimes they fight each other. You can have voltage regulators that fight each other. This is supposed to be extremely low dropout. Why is it getting so hot? They'll fight each other to maintain the voltage level, and that can cause like a cascade situation. So it's really bad. Unless the datasheet specifically tells you that you can parallel them, don't do that, because sometimes that'll break one, and then the other one is soon to follow. There's no heat in the TL074s. They're doing just fine. They're not blowing up anyway. I'm taking the right pins, right and left, GRGL. Gurgle. Forget Hawk-Tua, now there's Gurgle. Okay, so right and left, and then the circuit looks like this. So we have two op amps in this circuit, and they're on pins 7, 6, 5, and then 3, 2, 1. So 1, 2, and 3 are one set. Sorry, hold on here. So 1, 2, 3, and this pin is VCC minus. So if I take the multimeter, the ultimate tool, take it to ohms, and we go from here to -12, which is the stripe line, which is all the way over here. I get ohms. I get half an ohm. Go to this one, 1 ohm. Go to this one, 1.4. Now we go to the opposite side. This is what we got to do. And we go to +12, which is here, 2 ohms. What I'm looking for is low number. I don't use the beeper. The beeper is evil. The beeper will spoil you. The beeper doesn't necessarily tell you that there's continuity between two locations. And I get a bigger picture when I see the number of ohms between two spots that I'm testing on the board. That's an important facet of this. So output is here. So output, and then this pin has a 44 kilo ohm resistor on it. Now that's not a fixed resistor. Wait. No, yeah, the input resistor is, this is the other resistor. I decided not to use surface mount so that this is like laid bare before me and it was very clear. This is the input resistor. This thing is 100 kilo ohms. And then this feedback is 44. This should be connected to ground. And it is. That one's connected to ground, and then this one's connected to ground. No, this one's connected to ground. And it is. Check over here. Connected to ground. Connected to ground. And on this one, connected to ground. And connected to ground. So far, so good. It looks like I've done everything correct. What could possibly go wrong? These two should have something like 40 between them. Really, 29 is what it should be. And how? They don't. All right, so there's one that's missing a feedback resistor. Check this one. This is just your basic inverting operational amplifier circuit. So 30K, that one's good. 30K, that one's good. About 30K gives us the 3-to-1 boost, I believe. So it should be seeing +12. 0.7 M, oh, it's because these. 2.9, or 29 rather. And then this one, 29. Those are good. Output here to here should be 100K. Yeah, that's 100K. And then from this to negative input, again, 100K. Here, not 100K. 100K. There's nothing wrong with this circuit. I mean, it's going to technically want to output 18 volts because of the multiplication that we're doing. Wait, where are we coming into this one? Here. What's wrong with this one? Okay, and then this one here, 100K, and then we're going in here. Is it here? No, it's not there. Certainly not that one. That one's not getting in. Okay, so the bottom one here in the middle. This one to here, and then it goes and then it connects to the second over in what looks like a sloppy connection, but it's good enough. Maybe perhaps, no, not quite. Why does it do that? Wait a minute, what's it doing? What in the Sam hell? Wait a minute. There, and then this one goes up and okay, I see it now. I see it now. Well, it looks like it connects. I don't know where the break would be. All the way up to here where it gets this stuff, yeah. Why is that going in 3 directions? Could you clean a board like this from corrosion? I mean, yeah, I could toss this in the ultrasonic cleaner and get it nice and clean. You can use conformal coatings to mitigate corrosion, but this really won't corrode. This is silver. Silver and lead. It doesn't really corrode. Could it be that I'm not taking the audio grounds to a ground? We didn't do that in the main circuit, I don't think. If I were to connect those, I wonder if that would solve it. And what's going on down here? There's like an extra, oh, that gets us to the resistor, right? So this is the feedback resistor. It goes between this pin and this pin, and it's over here just because that's where I put them. A little bit more elegant on the top circuit. The bottom circuit is kind of crazy. Either way, it's all connected correctly. I just didn't get the ohms from it, and I don't know why. Let me reflow some of the pins and just see if it's maybe a cold solder joint. Yeah, well, if you don't want to use vinegar, you can use like, personally, I use an acetone derivative, and I don't let it sit for very long on the circuit board. That's the important part. You know, acetone is going to melt plastic. It's going to kind of harass your plastics down. And so if you're careful about it and only expose for a brief amount of time, it does wonders to pick up all of the flux and stuff that's on the bottom of the board. But I don't bother to clean something like this. This is just whatever. This is a whatever board. This is one step away from the garbage can. And the more it knows that, the more it acknowledges that, the better it'll work, because it knows that it's under threat. I don't take shit from my electronics. They know their place. Yeah, we need to just like reroute this down a little bit. Ah! Okay. Maybe I was wrong. Maybe it wasn't Maybelline. Oh, it's so ugly. Ew. The worst she can say is no. And then she goes, ew. That just looks terrible, but I think it connects. I have my controller for the gate with corrosion. Oh, I actually had a very similar problem from a friend of mine. He asked me to recommend to him companies that make conformal coating. Conformal coating is a polymer coating that you can spray onto electronics in order to prevent moisture from getting to the electronics. As moisture gets into this stuff, this is very cheap metal, it'll start corroding. Generally, if stuff is kept indoors like we normally do, I have circuit boards from the 70s that are fine. But if it's going to be outside in like a gate booth thing, in like an enclosure, even in an enclosure with seals outside, you know, moisture can get in, especially with temperature variances. I don't know specifically any brands of conformal coating because I so rarely ever use it. I run into it a lot. It's very annoying. You see them in automotive electronics all the time. It is just a spray coating. I would go from something from like 3M and just make sure that it's within the temperature tolerances that you're looking for. It should be, because it's conformal coating. And the conductive properties of it, I don't really know about. But if, you know, conformal coating, and it's supposed to work in the temperature range that you're going to see inside of the box, which is going to be a lot more harsh than you would think, that should get you there. And then you clean the board up, either with, you know, probably using electronics alcohol, clean the board up, get it as clean as possible, hang it up, spray it, let it fully dry, then put it back into operation. And you'll want to cover over anything that you want to have make like an electrical contact, because you don't want to conformal coat something that's supposed to pinch a wire, and then you pinch the wire with it, but there's a polymer coating on it and it won't make contact. So screw terminals, you can't really do polymer coating on. You could spray it afterwards, after hooking it all up, spray it, make sure it works, then spray it. But when it comes time to like change something on that board, you're gonna have to crack away all of that coating. So those sprays with a brush to clean like the contact, yeah, and painter's tape. You want to peel off the painter's tape after the polymer coating has gone tacky. But yeah, I don't have a ton of advice because I barely, you know, I've very, very rarely used conformal coating. What I'm looking at so far is that this circuit is fine, but it really doesn't feel like it's fine. Could it be? Actually, it probably is. The grounds on this thing are probably not connected because I didn't connect them. So we need to come up with a little jump from this pin to this pin. And then that needs to go to like this pin. Ah, man, geez, come on. My job here is talking to you guys, and it gets difficult when you have something like turkey chili for lunch, and that lunch decides that it no longer wants to be inside of your body. It's very, very annoying, and I hate getting burpy like that, but it's just what my body does. So let me check to see that this one is ground. Where's my ground? It was very delicious. It was actually very tasty chili. I liked it a lot. But it's doing a number on me for some reason. Which one of y'all is ground? You ground? Come on. One of you has to stand up and admit to being ground. I know it's one of you. Well, those are the resistors. So where's the other side of the chip? Is it? That's not ground. This is power. This is ground. Kidding me? It's not ground. This is ground? That one's ground. Okay. So this one here, I'm going to connect here and here. Okay, so that's easy. Perfect. Nice easy fix here. Hopefully that gets us up and running again. Because currently, I guess what I assume is happening is that it has no ground reference. And so the signal is just undefined. So it's all worth it. Yeah, I mean, it's just a vehicle for dairy products, chili is. I have my controller with the gate corrosion, and it doesn't work anymore. Oh, well, if it doesn't work, I don't know if there's... If it already doesn't work, I don't I don't know if conformal coding will fix it, but for the next one, you know, the one that you're going to replace it with, either check to see if there's already conformal coding there and or add. Because yeah, exact same problem faced my buddy, and he was like, my folks' powered gate doesn't work. Or not that it doesn't work, he's like, I need a conformal coding and I don't know what to buy. I'm like, I don't know either, but 3M generally is what I'd go with. Because that's what the shops that I saw conformal coding used. And those government guys know their deal. They know their stuff. This is unfortunately the power of me being an influencer. I tell you guys about products that I like, and some of you will go out and buy them, and that weirds me out. I don't know what to do with that. So whatever level this ground is at, it now has a reference for the voltage level to be compared to. Maybe that's where I went wrong, and it might have been a detail that I just sort of casually hooked up on the other board. I may have just been like, oh, okay, and then connected this, and everything was fine. How did I connect these on the other board? Did I do all 6 channels? I think I did. How did I do it? With these pins that go in this weird direction. I think I had yumpers on it. What up, Gonad? You're flooding around everyone's channels. Yeah, I think this is the problem, because everything else is connected correctly because I'm perfect in every way, and I am incapable of actually making a mistake. This is just an innate feature of me. It's not something that I can fix. The fact that I am completely perfect in every way. Yeah, it's clear. Yeah, that's the other detail. It should be clear. And I think that's the stuff. But yeah, first check to see that it works, then check to see whether or not it's already coded in conformal coding. Then mask off the stuff that you're not supposed to coat. Like a clock, if there's a little exposed crystal there, the crystal needs air. It actually has an air vent under it. So don't allow a crystal to be coated in conformal paint. Give it a little area around it where it shouldn't connect. And maybe you could do that with wax or something. I don't know. No, maybe not wax. I don't really know how you would do that. But you want to make sure that you're not covering over stuff that's going to stop functioning, like an IR sensor, you know, something like that. Then go to town on it. Let's see if that one works. We just did this on the first channel, and if I put this one in, we can see whether or not the error was not connecting ground. Make sure there's nothing shorting out onto the board. I almost killed this thing. This thing contains a lot of electronics that are not cheap. Where were you, little resistor? Those are probably the ones that we removed from the voltage regulator. Okay, and then power on and outputting waveforms. Okay, and now we get to see what's over here. Let's go to the spring arm so you guys can see what the scope's doing. There it is. Feedback. Same deal. Nothing's changed. Nothing has changed. Nothing has changed. Well, what the heck? Oh, ground issue on the probe. That one might be outputting DC. This one might actually be outputting DC. Although it's at ground, which is not really where it's supposed to be. This triangle is still there. Does that mean we get a triangle out of here? It does not. Out of here. Of course, I can't probe down here. Is it that our feedback is too feedbacky? If we put this at 100, 100, it should just be simply boosting this. And that one goes out and around, and it goes to this right here. I don't see any movement on that channel. Here's where it should be. Let's boost this. Oh, wait, no, not this. Boost channel 1. What the heck was that? Oh, we're way down there? At negative 11 volts. What the? Wait a minute. What are going on here? Okay, that's just affecting that. How is the offset so crazy? What the fuck? Okay. What's going on? Something be leaking? Yeah, that's super hot. Okay, so this all went really well on the breadboard, but now that we're on the perf board, we've got some kind of infernal offset. That's way positive. Well, it's at 500 millivolts. Is it millivolt? Yeah. Wait, 550 millivolts down to 11. What did I do here? Oh, I see. I drug this in a weird way. Let's just redo that to zeros. Okay, so there, that's at ground. This one is at negative 11, almost 12 volts. I don't know if it's a wiring thing. And here we have, hey, what's up, Wonky Robot? Here we have our feedback resistor. An offset so crazy is what I was used to with the $10 oscilloscope soldering project. I still have that. It's sitting over there. It would be fun to check that out one day. Been too busy with this stuff. Too busy. Turn her off and let's take a look at the circuit again. Something ain't right. Now, grounding those two doesn't seem to have had any kind of an effect. One thing I want to check is continuity between the ground on this board and the ground, what do you call it? The ground on the pin on the side, if they're just connected to each other. Oh, they're just connected to each other. Okay, so what we just did was completely useless. Those grounds are already connected. Everybody's already connected the way they should be. And I'm measuring 100 kiloohms on the input resistors. Why do we have such a... What's the plus pin doing on this one? What are you doing, plus pin? This is the one that's most inset. The one that we just did grounds on. So, according to the wiring, what do we have? We've got pin 1, 2, 3, 4. No, it's actually... Okay, hold on. I gotta find this thing and I gotta point to it. These right here. And so flipping this thing, we've got pin 1 is here. Pin 1 is an output that's got the red wire on it, and that connects to one of the two adjusters. then that also has an input that should be going to it from, well, wait a minute, is that wrong? Did I wire the amplifiers wrong? Pin 8, sorry, that's, wait a minute. I hate this, I hate through hole. It's the very reason. Pin 1. Pin 1 is here. Pin 1 going to the output resistor, and it also, this goes to the output. And the other side of the resistor has the input resistor from here, from the left channel, going into here. Left goes to pin 2. Yeah, that's actually going, I'm pushing on it with a screwdriver. That's not moving. These are the 2 pins of the feedback resistor. That one doesn't look very soldered. I'm going to hit that with some heat. Oh, if I had heat. No, I have heat. I have heat. I've got that music in me. No, that looks pretty soldered. I'm gonna add a little bit. Let's try. I don't know what's going on with this thing. That offset is indicative of some kind of a ground issue going in, because I think the only way you can get that offset is to put one of the inputs, the positive input, like put something on it. Maybe just part of the amplifier isn't really making a connection. Ugh, stupid song. Everybody hates me. I can't avoid it sometimes. Brains are crazy. They'll bite your head if you're wearing meat on it. No doubt in my mind that this is fully connected. There's nothing to worry about with this thing. So the other one goes around, and it goes to, because this is pin 1, 2, 3, 4, 5, which is a ground. In this case, it's the positive input. Positive input's on ground because it's ground referenced. Everybody's referenced around ground. This ground also comes diagonally up and over, and it goes to pin 3. So 1, 2, 3. And then 4 is negative VCC. That's this one right here. We know this thing is connected to negative VCC, although it is biasing all the way towards it. What could be causing that? Twist that little piece of wire right there. Could have been a couple pins that were sort of dodgy in their connections. Just make sure that everybody's happy and soldered. Sometimes this wire doesn't like to make a good connection. Make sure we're not cross-connecting anything. Make sure negative power definitely is coming in. We ohmed it out, though, so we know it's coming in. We know it's fine. Negative and positive. And then this is a feedback resistor over here with an unexplained piece of wire. Oh, is that coming in from somewhere? Huh. Oh, yeah, that's the wire that connects us to the output. Right. It's got to go somewhere. The signal's got to go somewhere. Our 100 kilo ohm input resistor is here, and that is definitely connected over a couple pins. It comes out and around and goes to 2 things. Why does it go to 2? It goes to, oh yeah, the feedback resistor, and then it goes to the negative input. And then the feedback resistors across the negative and positive. That looks like a break. And if it were not to get that feedback resistor, it might start acting funny. That might be wherein lies the rub. So let's try to push this thing over just a little bit. It gives us the reach to get over to there. Okay. Maybe that'll fix it. Maybe. Let's take a look. Yoink. And then put this in. Ooh, yeah. Electronics is a lot of work, and if you like doing this kind of stuff, sussing out the logic, figuring out where the little disconnects are, I've got good news for you. You'd be great at this stuff. Okay, so that's all plugged in again. And that is definitely, well, the top one is this channel. Let's give that another shot. These things use up a lot of current. It's actually kind of amazing. They're using a little less current. Oh, I've only got one plugged in. That's right. That's looking a little cleaner. That's looking like something we can work with. I think that one is just not outputting. This one could be a triangle wave. Indeed, it is looking like a 1 volt peak-to-peak triangle wave. Aha! Progress! This is why we do this, because sometimes it takes a shitload of troubleshooting in order to get your circuit to do anything that it's supposed to. Is that changing at all? No. Try this one. There we go. It's slowly growing. We finally reached that peak, and now we take this up to 10 volts. But what? Oh, the misery. God, that stupid song. Oh no, it's clicking. Our maximum amplitude is plus minus 5 volts. Did I do this wrong? We should be able to get all the way up to 12 with this. And I should be setting it to be 10 volt peak to peak. We've got maximum amplitude. What's up, Yasuno? How you doing? That probably means that we need to put a smaller resistor into the input, and we'll get more voltage out of it. Now, are we doing anything to lower the amplitude here? The amplitude should be, oh my God, that's screen stuff. Hold on. Oh, the misery. Amplitude is 1, which I think is max. Check the voltages coming out of the pins. Make sure that it's 6 volt peak to peak. Channel 2. That should be huge. It is huge, but it's not quite 6 volts. Almost 3 volt peak to peak. 2.9. Yeah, 3 volt peak to peak. That's right. 6 volt peak to peak. 3 volt max. Positive, negative 3 volts, because it uses like a charge pump to make negative voltages. So that is correct, but my adjustment isn't. My adjustment isn't quite where it should be. We have 100K pots in all positions, so I can go maximum 1-to-1 if I have that on the feedback. I guess I need to have like 80K on the input. I need to change out those resistors, the input resistors, because we need more coming in, and then we can cancel it. No, but wouldn't it be a smaller resistor, would have less feedback, and it would do less cancellation? But I've maxed out the smallness of the resistor. Let's do op amp calculator. My O key doesn't work. Come on. We really need to resurrect that keyboard. So we are in this configuration here, the inverting amplifier. Inverting amplifier, resistor R1 is 100K. Feedback resistor is up to, and if we go for 33K, and then our input amplitude is 6 volts, we get 1.98. I see. So my feedback resistor can go down from 100. So if we have 100, that means that we are going to have the same amplitude on the output. If I let this one, take this one down to 50K, then we can get up to 12 volts. So now if I go down with this one and I go to 50K, I am now at unity gain. And if I get to 70, my output amplitude goes down to 8 volts. If I go to 40K, we're at 4 volts. So I guess we'll take it down to 50, and hopefully that solves all of our problems, and we're super popular, and everybody loves us. Now for these, because the through hole, I can just clip them off. Ow, why is that so hot? I really need to find, I think that's 500 millivolts, and this whole thing is taking like 200. So it's kind of stressing it out a little bit. So we need to replace all these resistors. No, I'm not going to put pots in because I don't have space for them. We already have pots. I could put those little like flat potentiometers down here, but now we just needed to run some equations just to solve our idiocy problems. With these flush cut, I can pull them out from the other side. And then new resistors should be easy to put in. Push comes to shove, I could have gotten a bunch more 100Ks and put them in parallel. A wonderful relationship between parallel resistors. Okay, let's clean up the board. Find that I'm always just cleaning up this board. Not putting a coin on there. The coin would make a nice big fucking like press that would injure me. I'd have a coin indented into my palm in burnt flesh. Blah, 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 blah. Tweezers. Where are my tweezers? Oh, there. Hiding. Okay, so we need to do a little solder removal, and then we'll do a little bit of resistory stuff. This is kind of tough to do. I need to come in flat and pry through. Pry some more. Man, I have not put any more than like 10 minutes into Stalker 2. I would like to play that game a little bit more. It'll be fun when the mods start coming out, but I haven't been able to get much gameplay in with that. High speed coin. Well, I'm not quite getting explosions. We didn't get any snow here. It was a little bit too warm for snow, which some people think is good, but I kind of wanted snow. I want deep snow so that the dog will play in the snow. And then I can join you joyless people in hating snow. People are joyless. I don't really understand the hate for snow. I love snow. I think it's amazing. I especially enjoy driving in the snow. That is correct. I actually enjoy driving in the snow. I like doing it. I'm not like you mere mortals. I don't mind shoveling. We had enough snow to stop me getting out of the street on my summer tires. I still do have summer tires on. I gotta do that change. They're sort of just permanently on because I don't expect things to get cold. Oh my God, that was a big meaty burp and it really hurt. I need to get a sip of water. Snow's fine. Cleaning it off the car is not. It depends on the type of snow, I suppose. I will give up that point. It depends on the type of snow. Sometimes snow's a little bit tolerable. Sometimes it's awful. I understand. I get it. I get it. I love snow, but people stop functioning as soon as the first snowflake hits the ground. It's kind of amazing to me that Houston can get like a dusting, or like South Carolina can get just like a little dusting of snow, and people are just flying off of the highways like they're driving stunt vehicles. Yellow snow is the worst kind. I'll give you that one. I will give you that one. Wait until life works if you don't want to focus on exploration only. Huh? Oh, A Life? You mean the like a mod for Stalker? It would be nice to get it to be like more of a part of Chernobyl kind of thing. Damn it, I can't. I didn't play those games though. I didn't play the originals. There's so much flux on my tweezers right now. I've been doing big through-hole soldering with it, so it's. But I need to grab this and twist in order to get it to pull the pin out of the socket. See, and then it's going to want to drop in to that hole. When it does that, it creates the exact same issue on the other side. And now I've got this partial pin sticking through. It's actually not on the other side. Where is it? Where did you go? Oh, it's on the end of the tweezers. All right. Stupid fluxy tweezers. I want to be cozy and warm indoors where I can do all of my soldering. Although, to be fair, if it was cozy and warm and it was absolutely going fucking crazy outside with snow, I would unfortunately be reading up on the minimalist UI screen stuff, because a lot of what I'm about to do with this revolves around that. I wanted to get to that today. Can't. But once we know that hardware is all set, I will be able to do the UI stuff and have that effect change. There's all kinds of ways to do UIs. This one is just a fairly minimalistic one that you can do on little monochrome displays. So I think it'll be pretty useful to get to know. Because we have a big monochrome display that I have to get to know. And I'd love to learn how to do animations and stuff too. Maybe that'll be a use for Blender. Get the chip emote into Blender, and then I can do stuff like have a camera pan around and make each individual frame of like a cool animated logo for when you boot up the screen. People do all kinds of crazy stuff, but and also maybe I could just do LVGL display with and just monochrome it and throw it up on this thing. The ambient groups that fight each other aren't working properly yet. It's coming in a future patch. The game itself looks beautiful, yeah. And I actually saw somebody running it on the Legion Go, and it was everybody in the thread was like, "Why did you do this?" Like, because they had to turn off all the effects, all the like next gen like grass and stuff wasn't there. It looked terrible, but it was funny that it was running on a Legion Go. I have a Legion Go. I bought one. I spent all that money on it. So that I could take it to LAN parties. And actually, immediately upon buying the Legion Go, my friend backs out of the December LAN party. He goes, "Oh, I can't really do it. We could do wireless, do a WAN party." I was like, "Of course, as soon as I buy this thing." LVGL is not the planet that they go to in Aliens. LVGL is a screen design, like group of code or something. There's like a GitHub for it and everything. You can purchase it, but you can also just use it. And it allows you to do nice looking screen stuff. You can do like professional screen stuff with a color display. And it's got like a designer for you to design all the stuff, and then you can port it over to your machine. Very useful. Is LVDS what I'm talking about? Is that what you're doing? Is you correcting me? Because I thought it was LVGL. I don't have the internet to verify. I'm much less smart when I'm on stream. I don't have any reference. LVDS is for laptop display. LVGL is like a code group. Oh, that's right. Low voltage differential. LVDS. That's for displays. Yeah, embedded small screen is LVGL. Yes, good. Good. Okay, there's that. Now I need to go get some 50 ohms. Let's go shopping. That would require a working mouse so that I could switch scenes. There we go. Cables are getting under the mouse. This is just what happens. 50 ohm. Now I've got these 33Ks that I could put in, and they would probably make the math correctly. I think we should probably go for the 50. Let's just see how close we can get to that. And I'm going to need 6 of these, so it's going to pretty much use up a whole stack. I mean, if these are being corrected, I could use the other group. But well, let's find them first. So 50K. I don't think I have 50K. I think it's going to have to be near enough. 56 is as close as we're going to get. 47, actually. Yeah, 47 is the closest, so we're going to use 47. 1, 2, 3, 4, 5, 6. All right. This is resistor setup is a disaster. I don't know what I can do about this, except maybe relegate it to individual resistor bins, but nasty. Nasty, nasty. All right. Nasty. Let's get this over here. I'm going to use this thingy. I don't know how people do anything with screens. I know Ben Heck had a whole video where he utilized screens to do stuff. He, like, figured out how to engineer for a screen. I could not do that. Oh, I didn't remove the solder from this one. One sec before we get into this. I need these pins to be available. Where are the pins? These two. I thought I got those. I guess I didn't. Even this one. Oh, come on. Gotta catch them all. Oh, come on. Yeah. Check the others are clear. The others are clear. This one is not. This one is not. Rah! Upir on YouTube. I was looking at Upir's code for his little screen thing the other day. It was the one that we first stumbled on. I guess Upir gets around. It's 2 eyes, I believe. Small series where he showcases different displays. Maybe something for you. Maybe. Yeah, Upir had stuff about the U2 blah blah thing that I'm using. I remember because people were excited when I found it in chat. They're like, oh, I forget where they're from. It's not Ukraine. Turkey? I don't remember anymore. Upir is good for inspiration, but the documentation for the actual library that I'm using is really what I'm going to fall on and use for the most part. And there's a wealth of examples. There's all kinds of amazing examples of what you can do on the screen with very light code. So I just need to learn it, and my big problem, I'll be frank with you guys, my big problem is that I don't have my ADHD meds. Those engineering tasks that are sort of high, like large amounts of work for very little payoff are very hard to motivate my ADHD-addled brain to do. Those low dopamine tasks, I need to have powerful drugs in my system in order to get me to do things like that, and my taxes and things like that. It is very tough. And I've been making progress, but it's, I have to rely on every single know thyself sort of thing that I can employ. Lots of caffeine, sitting myself down and shutting off any distraction. And then Willow comes in and she curls up at my feet and sleeps under the desk, and I die of absolute cuteness and don't get anything done. But I've been making progress on it. It's just a lot more complicated because it's like, I can do this thing, and this is exactly what I wanted to do, except it doesn't work with floating numbers. Why doesn't it work with floats? You gotta keep all these little details in your brain. Where's this going between there and there? Just like that. So this will at least allow me to adjust the channels. We still need to troubleshoot all of the other channels, but at least we know now that we have the correct hardware in place. I do not like through-hole, but I'm using it begrudgingly in order to put this thing together in such a way as to allow me to edit things easier, or just to see what's going on. I don't know. I don't know why I'm going with through-hole, to be honest. Chip resistors are great, especially in a system like this. Probably should test this before I deploy all 6 resistors. Too late. Too late. Too late. Too late. Wind's howling. Through-hole's nice for prototypes. Yeah, I don't know. I appreciate surface mount in everyday situations. I enjoy working with it to a great degree, actually. And it makes slightly more compact prototypes. I realize it's not for everybody, but I mean, even like the audio heads, I would have encouraged, if I made that mixer for 6-channel audio and I made it in a way that was repairable, I would still use surface mount chips just because I think it's the better technology. But I guess that wouldn't really go with the philosophy, though, because audio dudes probably not as good at doing small stuff. They're not specialized like I am. Then again, surface mount soldering should be right there with through-hole. We should be teaching it instead. It is it's not even modern technology anymore. Don't get left behind. Well, actually, we should do leaving behind. We should leave behind. Lead by leaving behind. You missed my selection of intro songs. I played the healthcare waiting music, as well as Filter's update to Hey Man, Nice Shot. I forget what the title of that song is. Bend that down, bend that down. Next. These dogs are going crazy. It is gusty out there, though. There, and then this one goes this way. There we go. All right, number 2. I like that song, but it was played at every sports stadium in existence almost in perpetuity since its release. It's like watching lacrosse. Like, this is a weird fit. This is a weird fit. I don't think this song really fits with baseball. Like, I know it says nice shot, but that's not what they're talking about. They're not talking like a shot on goal. That's why I say, hey man, nice serve. What a good pickleball. Not the point of the song. Nope. Nope. The meaning is very far from encouraging a nice sports ball interaction. Yeah, it just keeps happening too. They just keep going. They go into their bag of music and they go, well, Raging Against the Machine kind of represents us, right? Let's play Rage Against the Machine. And it's like, guys, you're the machine. Like, you're the machine. Like, I don't know how else to tell you this. You shouldn't be playing this music. These musicians fucking hate you. Born in the USA. No. I encourage you to read the lyrics. Next. Now, while this will allow me to tune it, it still doesn't solve all of the problems that I'm having. I'm having a lot of hardware problems, possibly due to the soldering, that are affecting this thing and not allowing it to work properly. It's also possible that maybe this thing just works properly now that I'm able to amplify the signals to the degree that I am. I can get it up to, I think it was 18 volts we got for the proper amount of gain. The thing about, oh wait, there's still stuff in there. What's going on with that? Oh, that's from, okay, that's fine. The thing about op amps is they've got a gain of like 300, and what you're trying to do is feed back the opposite waveform into the output of the op amp, and that'll tamp it down. And so when I put a smaller resistor in, it will have less of a tamping down effect. You can boost. If you're inverting, you can boost quite a bit, and you've got sort of a bunch of gain to play with. So that's why you choose inverting op amp instead of the non-inverting setup. But if you're attenuating a signal, if you're lowering a signal, the non-inverting op amp works quite well. In this case, we are generating these waveforms here. So the phase doesn't really make that much difference. We are making the waveforms here. If we were mixing a waveform, an external waveform back in, we might want to make some consideration for the fact that this is changing the phase of the output, and it can cause some weird interactions when you go to like mix a phased and non-phased signal. There will be a little bit of a phase delay because of what we're doing, going through the op amp, but it doesn't matter because nothing else is using that signal ahead of what we're doing to it. So it's perfectly fine for us to flip it on its head. Right here. Almost there. Slight correction of our input amplifiers so that we can get a little bit more current in, and it'll allow us to boost the signal output without changing all the potentiometers. Otherwise, I mean, I could have changed all the feedback potentiometers and they could have been a different value, but this will be fine. We're barely using any 12 volts as it is, so this will be perfectly fine, although it doesn't save that weird offset that we had. And actually, to be fair, if we do DC output from this thing, I'm going to have to somehow make it negative DC output. And I don't know if the library that controls I2S does that. I don't know if it does that. It does positive DC, but that'll be inverted and be a negative output on our part. So if we wanted like a positive 8 volt square wave, we're going to have to make a negative 8-volt square wave. Let's just see what we got here. Bonk. And then we'll put in channel 1, well, this channel. And we'll use the bottom connectors. And maybe, just maybe, oh, because I was so sloppy about that, some of these are sticking up. That's okay. Doesn't need to be perfect. It does need to work, though. And for that, it needs to be perfect. And then we're going to plug in triangle wave. And we're going to plug in power. That's why I say, hey, man, nice shot. What a good shot, man. Scope's on. Power on. Okay, not much has changed. Although this is all the way at an extreme, isn't it? What if I lower this? It goes down. We didn't gain anything out of this. What the hell? Aw, come on. Yeah, this is where we max out on our 100K feedback resistor. I was told that if we had 6-volt peak to peak, what if we have 3 volts and we're at 50 and 100? Well, gain of 2. 3 volts gets to 6 volts. So, I mean, this should have more of an effect. Why did this have such little effect? What does our original output look like? Let's get ground over here. I have to really troubleshoot this stuff. That's just going to be in my head all day. This is like a nothing burger signal. What's going on with you? What's going on with you, man? Where's my signal at? This may not be fully connected. This is one of the ones that I used on the probe. So the probe kind of stretched out the internal springs. And I can always stretch them back, but that means taking off the shroud. Oh, this isn't connected to anything. There we go. There he is. So the scale, actually, what's scale number 1? Oh, there we go. Actually, we are not at 10 volts. I want 10 volts for my audio signal. But we are at, I can measure that. Measure. And we'll do Vmax. I don't think I really need VPP. Well, I probably should have VPP. Do you guys want to measure my PP? Yeah, we'll measure my PP. We'll do that. And so my PP is 13. We should see 12, actually. Let's do a Vmax on that, just so I know. 6.7. It should be more than 6. It should be, my PP should be 20. That should be at 20. I'm not getting the gain that I should be getting out of it. Yeah, the first one is at about, well, the Vmax on the other one is 2.9. So we really do have 3 volts into 10. So if I had 3 volts and I have the values that I have, so the values are just still bad. What were the other values for the input resistor? Let's see if we can possibly lower it again and then get the proper amount of gain. If this one is 33K and we're at maximum, and I calculate that, now I've got 9.0. So we actually need something lower than 33. Darn, I have all these 33s too. 27? 11 volts. So that should do us just fine. So it looks like we have to use 27K resistors on our input. And I don't think that's going to have too much effect on the amount of current that this thing is using. Yeah, I should have calculated a little bit more. I should have studied my books better. That's on me. 56, 47, 22. Oh, I don't have 27. Well, 22 will get us to 12. 15. Jeez, probably want 27. 47, 22, 15. 27 is missing. 75, 56, 68, 82. Yeah, okay. 1, 2, 3, 4, 5, 6, 7. I have one resistor left at the end of this. It has to be done. Although I could use the non-1% because I am tuning this afterwards. But we'll just use this. All right. So that will mean that all of our channels have the appropriate amount of effect to get up to that 10 volts at maximum amplitude from these drivers. All right, power down. Now I got to let it cool off because this thing gets hot enough to burn me, apparently. This regulator here is quite angry. And no, I will not attach a coin to it because that means I'll burn my hand on a coin. Do we have any? What happened to my copper? I don't know if I want to make the surface area any larger because then it'll just burn me better. I could solder a bolt in there and it could help dissipate the heat, but that would just mean that I've soldered a bolt onto this thing and it's now angry and willing to burn me. A piece of a tube, a tuber. That's all water cooling stuff. I kind of don't want to use any of this stuff on specific electronics things. Hold on a sec. I can dig deep and I can find a heatsink. They'll stick it in your face and let you smell what they consider wrong. That song is going to be in my head all month. Thanks to the happy doings of stuff. There should be heat sinks in here, but there are not. You would be wrong to think that there would be heat sinks in here. This is the laser bin. It should be full of heat sinks, but there's nothing. All right, hold on. I gotta dig further. Let me bring you guys over into my world. I have this thing for a server. This is a little bit overkill. I don't think this is what is called for in this scenario. Somewhere around here, there are a couple little copper heat sinks that I use on various things. And I think they're down here, actually. Get the glue bin up. There was kind of a little bit of an avalanche over here, so I need to neaten up. I haven't had the time. Well, it's more like I haven't had the motivation. Those are weird parts. Something. LEDs. These are sewing bins from Michaels. And they're really good at holding little projects or just stores of parts. 3D printer, does that have anything heatsink related? Nah, not really. Unless I put an active, put a fan on it. I have 10mm fans. I'm not putting a fan on this. It's stupid. Don't be stupid. Why I say, hey man, nice shot. What? Something got stuck in this one. Whatever. Nah, I can't find them. I don't know where they are. I have some little bits of copper that we used on my computer project, and there should be just a little tiny heat sink in that bin, but I don't know where that is. It's going to take me too long to find. We need to put new resistors in here. We need to do the same thing over again. We're going to be here for a little bit. Try to do this same operation, just do it again. I also, at some point, we need to pull these apart, and I need to put LEDs in them. I want LEDs in them, little yellow LEDs to light them up. I don't know if I can play them from behind, but I illuminate them from behind. I don't think I think the material's metal, a little faceplate. If we're lucky, it's not, but I don't think that's the case. I should have put sockets down, and then I would have been able to plug resistors into sockets and have them configurable. Would have been a good way to do it. Well, you don't expect to have to swap these things out. The adjustability is in the potentiometer. Although it seems like if I just fixed, if I do this fixed, then they'll all just output 10 volts. And you were right, but they were just too strong. Oddly relevant song. Ah, get off of my soldering iron. Wind's howling out there. I wonder what the weather's like. I gotta take my doggy for a walk soon. Not immediately, but once we finish this and I guess get that output tested, I'll have to look at the individual circuits for the other ones because it seems like little errors in the soldering are probably what's going on, and I got to get it down to the multimeter in order to figure out who's doing what, and potentially where there's little breaks and weird parts in the circuit. Like this here, this is supposed to be connected. I had to bend this over to get it to connect. I don't like the look of it, but you know, that just ensures that both of these are definitely connected. Those little things are what kind of kill these circuits. They're all solvable. I can get over it. And twisting motion is important with that. You got to pull what's left of it out, so it kind of wants to fall down with gravity. But if you can get the tweezers on it in a flat position, then you twist and it'll pull the thing out of the hole. It's the fastest way that I have for removing through hole. Everybody wants to use hot air for everything, but no, that's not the fastest way. It is not the way. All that flux in the tweezers, got to pry them apart. Look at this. This ended up being a physical building day. This is taking a little too long, but when we're done with the signal generator, that means that we can do a full test of the mixer using the parts that I'm going to be putting into the actual PCB design. And then from there, what we'll be able to do is do a couple AutoCAD streams where I'm putting the traces down and designing all of the PCB facets. Then I can order it and we can build a test. And then I can get Julian to try to sell it. I can make a couple bucks off of it, or at least make my money back that I've been putting into the stupid mixer project. Because he's pretty confident that people will find it useful. I'm not totally on the same page as him with that, but I'm willing to build it because it's an interesting project for you guys. And why not try to sell it? I don't know what kind of stuff I have to worry about for selling a product, though. If I sell it as a kit, I guess that's probably the best. It's for your own experimentation. Any results from my kit exploding in your face are not my fault. This is a product for experts. And if you break it, that's on you. I'm going to put diodes on it because I don't trust anyone. I've lost my ability to trust. It's atrophied over all the stuff that I've had to repair. But once I get the signal generator made, we'll also have a signal that we can put into the M303. And we can see the M303's output. I have one op amp to replace on that to test. It's that little 5-pin Jimny John. And once I test that, that means that, well, that is the only thing that I think could be keeping it from outputting full throat. Because it's really the only thing that I haven't replaced in that circuit. Extensive knowledge of the M303. I haven't looked at the output section, though. I haven't looked at that yet. We've a bunch of reverse engineering to do on those. So I have both Dave's M303 and the one that a viewer sent in. And I feel bad for that viewer. but they were like, it's broken anyway. Like, I'm not going to magically fix it on my own. It just makes me feel bad if I'm not furthering something that somebody sent in or completely destroying it. Because remember, and this doesn't really apply to that user because I didn't actually set the ground straight for them because they're sending their precious broken synthesizer in. But sending things to oh bother, typically, remember the synthesizer is an atypical thing, but sending things to oh bother is akin to throwing it in the garbage. There's no express guarantee that I won't destroy it on air or not mention it in any way. I typically do give credit to the things people have sent in. I like to give credit to the things people have sent in. It's encouraging and people love to see it. But I'm laying it down clearly that I have no obligations. This isn't the type of show where you send stuff in. We have had a couple whales on the stream, and I try to be resistant to that because it's not fair for everybody if it becomes the one user show. It's the rich person's show who sends in stuff that they want me to review. It's like, nope, not doing that. I know it's not great for growth, but whatever. We're lucky to have the people we have in here. You guys are great. I like my community very much. Otherwise, I wouldn't be streaming. Oh, my thumb is so tired. Okay, God, the solder sucking has been like a constant for weeks just because of this proto board design. You know, I'll mess up and have to suck solder from like everything. Give me a tube, a hose and a golf ball and a goal. There's that. Distance. These are all like stuck to each other because of the adhesive that they use to put the paper hangers together for these paper organizers. Man, electronics are weird. It's so weird that the way that you buy these things is on like a piece of paper that sort of hangs them all together, and then that piece of paper fits into a mechanical wheel that advances them into a machine that'll deposit them into a circuit board. But we as consumers buy them like that. What they'll do, because you only bend the leads so much, and so it'll fall in a little bit, and that's what makes them kind of like elevated. Makes them look sloppy. I think I cut the wire. Okay, though. This is bothering me. They are flush cutters, after all. I mean, flush cutters. Solder? Oh, it's over here. I need to bend that down. Tweezies can do it. Enough of it out there? Yeah. Now it looks like I gotta heat it up. Let's get that little bit of wire just straighten out. Ah, it's not doing it. It's doing everything that I don't want it to do. Give me this. All right, you hold on right there. And this can just be flattened in. There we go. Okay. That fell through, so this resistor needs to be pushed from underneath. Sneaky little bastard. Huh. That, I guess the cutter got it a little too close. What I could possibly do is grab it with the end of the cutter and pull on it a little bit. It just gives me that little bit of extra. You got to be careful with doing that because if you pinch it too much, it'll just simply cut the wire. But you're using the wire cutter to kind of get a grip on that wire. It can just as easily break it completely. So you use a gentle mom, and that'll hold on to the wire itself and give you a lot of ability, a lot of torque. Is that torque? It's not torque. You get a lot of force on the wire. Okay, next two. Probably just do the ones on the end and then leave the others for later. But oh, I didn't desolder this one. Those that were right there. A new kind of fear. I have a new kind of fear. You fight and you were right, but they were just too strong. The Muppet Show. Ah. Everybody has a bubble voice. That's not a unique voice. There we go. Man, if they could have kept the Muppet Show going through the 90s, the old one, we would have had some weird song parodies for sure. I would have loved to see some of the grunge parodies that they would do. Instead, we have legendary 60s and 70s music. Okay, and then get this one. We cut the leads. It's confusing to look at from this angle, but I'm getting very familiar with the design of the circuit at this point. And this method of doing through hole doesn't look the best. It doesn't look the best. I don't know if there are other methods you could do this stuff with. This is just the one that I learned. I would be curious if there are ways to make this cleaner. But largely I use this technique for through-hole stuff. Or sorry, surface mount stuff on a through-hole board. No Willow, she just does not like it when I stream anymore. I guess she likes to take her afternoon nap. But that means that I don't see her until the sun goes down. She's been very cute today. She jumped up in bed and was harassing me about taking up too much space and over the covers. I think she does it because my room is like an observation deck for the front door. So when she gets kicked out of the front door for being too loud, she'll come up to my room where she can still monitor the front door. She has one purpose that she has selected for herself. It's by no means have we encouraged her on this, but she has assigned herself the position of guard dog. So everything she does is in service of keeping us safe from monsters. And I have yet to see any monsters, so I mean, she's probably doing a pretty decent job, if I'm honest. If I'm honest, have I seen any monsters? No. So I guess I can't fault the job that she's been doing. The Borculator, yeah. She is a loud dog, but we got extremely lucky that she has a baritone voice. She's a bit of a baritone. Our neighbor has an Irish herder, so another bubble butt dog, much larger than Willow, but has a much higher pitched bark, which is, oh my God, is that annoying? Have just a boo, 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 like a really high pitched alarm going off. What am I cutting? Oh, I'm all the way over here. What a good shot, man. Say, hey man, nice shot. Oh, we cut these from the other side. That way the pin doesn't overreach where the other one is. And it just gets it on the pad. Oh, it doesn't even need to be laid down? What's going on with that? Weird. Okay, well, that'll do that. Now I just add solder to the whole thing. Make it look like a bunch of crap. Makes it look like a blobathon. All right, so we are ready to test this. See if it does the wobulating that we expect it to do. Now that we know that all the equations are on our side, really should have run those numbers before I did this, but oh well, here we are. It's what it's. Get all these tools out of the way. I will not be replacing these again. If this goes wrong, this whole thing goes into the garbage. Now that I've got all these are the leads that my socks will pick up, and then they're like little syringe tips. They poke the crap out of your leg or toes and stuff. It's awful. The worst. So I got to make sure I get all of them. And especially using those flush cutters, the Nipex, really good flush cutters. They cut very flush. They cut very flush, but they certainly do like to make a nice pointed tip out of the wire, which encourages it to embed itself deeper into your foot. You gotta go get a pair of tweezers and pull that fucking thing out. Luckily, I know about them ahead of time. They hurt like hell. Since these are not quite 0.1 inch, I need to make sure that it plugs in properly, which means kind of sliding it down at an angle. The whole thing plugs in just kind of sideways because of that. It's not quite 0.1, it's just a little bit off, and I didn't want to make slots for it. So, we have one driver in there. Plug this thing in. Turn it on. Our output here looks like a triangle, but it cuts off because we don't have enough volts to get up to 15. So now I can turn this down. This is what I expected to see out of this thing on the first try, but I did not. So now our VPP needs to be 20 volts, and we need a 10 volt Vmax. So this is about where we should be. That's going to wander around with heat and stuff, but that should be relatively accurate. This is what we want out of every channel. Let's take a look at the DC output and see if we can change that one. How much current are we using? We're using something around 100 milliamps, so something is fixed. Oh no, we're only using 100 because of this. I see. These things use up a lot of current. I may have to look at a different voltage regulator for it. But let's go to the program, our simple test program, And let's make sure sine, sawtooth, sawtooth reverse, square, triangle, sine. We're not outputting a DC, but patch cord 5 is DC1 to 0 to I2S oct 1. I2S oct 1, I2S oct 1, pin 4, 5, 6, and then pin 1 is on DC1. So we want to turn that into waveform 3, 4, 5, 1. So waveform 2. And let's upload that to the teensy. Let me plug it in. Plug. Oh, geez, the plug on the teensy is not the best. I really wish he had gone to USB-C for the teensy 4. Oh yeah, those the little coily guy things. Yeah, those are nasty, nasty. Upload. It's going to try to save, and access is denied because this thing's trying to save to a server folder that it doesn't have the permission for because I have not been able to get into the settings. I've not remembered to do that. Is it really going to do this every single time? It's got to compile like 2 different enormous libraries. My TC2 only works with 1 USB mini cable. I think I need to put a new socket on it. That's so fiddly to do too. It's such small work. I've done a lot of it, and I've got a lot of the sockets. I've got a lot of the spare sockets sitting around. What I have more of is USB-Cs though. I wish I could figure out some kind of a replacement because those USB-Cs are strong. They're good connectors. They finally learned from all of their freaking mistakes that maybe it was better not to make the connector like not solder the anchor pins. All right, we're back here. Waveform. Let's check this one. Son of a bitch. I thought that would be that would have been the answer. I think I'm gonna have to fight this thing channel by channel. Wait, but you're not actually outputting anything. Is this a programmatic problem? What's LR clock doing? Looks like all your clock signals are okay. Yeah, there's that one. There's this one. And there's this one. They look the same over here. 1, 2. Oh, nothing there. Nothing there. Wait a minute. What is going on? Oh, maybe because they didn't respond. I think some of these clocks are coming out of this thing. Yeah. How hard is it to make a wave wibbling wobulon? Try restarting. Nothing happens with that. What the heck? Oh, wait a minute. Well, we know this channel works, so I should be seeing an output there. Let me use the actual pokey bit. That might clear things up a little bit, as it is pointier. Yeah, I should absolutely be seeing a signal here. And we are referenced to, we're plugged into channel 2. Channel 2 is at, yeah, 2 volts. So that should absolutely be, oh wait, but our main output isn't outputting either. We're not getting anything on channel 1. What's going on? Come back to me, man. You go off, you go back on. There we go. I mean, maybe poking the signals caused something. Oh, but why isn't that outputting? What the heck? The buttons don't do anything. They're just window dressing. Okay. This thing is making me tired. It's just making me tired. Is this thing going into thermal shutdown? I bet you that's it. I bet you it's going into thermal shutdown. And that's what's causing the weirdness. Well, no, because everything else is powered. Yeah, there was a little signal there. Hold on. I probably need capacitors on this thing, to be honest. There it is. Okay, there's our signal. So that is at 3.2 volts. That's perfectly stable. There's our triangle wave. Look at it go. What the heck, man? And it's not in either of the probes. Reset. No? What's VN look like over here? There is no VN over here. What the? The LED's on. This is absurd. Oh no, here's VN. Okay, that's at 3.3 volts. We haven't dropped down in voltage. We're still doing okay. But for some reason, we don't get any waveform output until I turn this thing off and on again. Off, on. Then we get all of our waveforms are outputting all at once. But if I go over here, I get nothing. Good day to you, sir. That channel is channel... Well, I actually don't know which channel that is. They all should be outputting waveforms, though, because we began all of our waveform 1 through 6, and we've got waveform 1, 2, 3, 4, and 5. Oh, maybe there's not a... No, we're skipping one. That's right. Wait, hold on a minute. Waveform 1, 2, 3, 4, 5. We need a waveform 6. That's what it is. It's a software thing. What are the 7? I2S1, blah, blah, blah. Waveform 1, 2, 3, 4, 5, 6 to octave 0, 1, 2 and 3 we're not using. 4, 5, 6. Wait a minute. 0, 1, 2 and 3, 4 and 5, 6 and 7. 0 through 7. Okay. Try that. Do I have a waveform 6? Yeah. That's going to be sine. That's what it is. I forgot one. I left it out. I'm missing daylight. Ugh. I have to walk the dog with a flashlight. That's why I bought an expensive flashlight. Also because it's cool. Oh, no teensy. Doody doody doo, doody doody doo. Dee doo dee doo. Okay, plug you in. Hopefully the plug doesn't come with it. That is plugging in way too smooth. That was weird. That was weird. When a USB port doesn't click, it's I don't know. I don't like it. Well, eventually this one, no, not this one. The other one's gonna get the teensy 4.1 is gonna get its own USB-C external plug-in to program it. Done uploading. Okay, so now we should get some kind of a sine wave on this channel. Ah, there we go. Look at that. Beauty. It's a beauty. Oh, she's a beaut. So that's almost at 10 volts. We just need to do a little bit of adjusting on it. What's my VPP? 15, 16, 19. Almost there, almost there. The thing about these is that they slip off really easily, and I had a wrench that was specific for these. I think what I need to do is print out something on the Goop printer that will have exactly the radius of that little adjustment thing that can like slide over the tip of the screwdriver And that way it'll just sort of keep itself on there. All right, cool. So now we got 10 volt peak to peak out of that one. Next channel. Bonk. What a good shot, man. I don't know, just some random tune that's in my head. Nice, nice, nice. Very good. Super excited about that. No waveform at all. No output. So are we missing a signal? That would tell me that something is missing over here. And it's VN. It's VN that we're missing. So good. It does well. The LED is on, so I don't know why I'm not getting any kind of a measure. Did we turn off this channel? Oh, I think we did. I think there it is. Okay, accidentally turned off the channel on the scope. Yeah, no waveforms coming out. And if there's no waveforms coming out of any sort, I'm inclined to think that something's wrong with the digital stuff. For instance, DN might not be fully soldered. If DN is not fully soldered, then we don't have any signals coming in. So that's possibly the problem area. Serial clock is good. SCK doesn't have any purpose. DN, LR clock? No LR clock. Ground we can't really measure. And VN is at 3. So let's check those digital pins. Ow, I touched where the voltage regulator is. Super hot. That's here. We are here. And these are the pins in question. They could use a little work, but I think they largely look connected. They're a little sloppy. Oop, iron turned off. Is this really the pin header? Yeah, because there's the op amp and here's the pin header. I just got to ensure. It looks like that's a gap. We have an unconnected pin. Dun dun dun. I'm gonna have to pull on it a little bit, so I'll have to get the tweezers on one end and get both of these molten so that I can pull and hopefully encourage a little bit more of the wire to come through. Dang it, come here. These are not very grippy tweezers. The alternative is just drop a piece of wire down on it. I guess we're gonna have to do that. So I've got plenty of those. Where'd that connection go? That was this one. It's any wonder this thing worked in the first place. Please cooperate. Does that one look connected? It doesn't really look connected. This is the specific one that goes to this and gives it its signaling. I'm just looking at blobs. Oh yeah, it is connected. It's all the way over here, except there's a little bit of gunk in it. We're gonna gunk blast it. Gunk blast this stuff away. That might have been preventing a connection. There's like a little bit of a jacket on the end. There we are. There's that wire. Be absolutely certain that that's making a connection and not hit that pin right there. Let's not do that. All right, there we go. I'm going to do just a little dollop of solder on it, even though there's already too much. Just to make sure we get a little bit of flux on this side of it, and that that resistor wire properly settles in and makes all the connections it should, which should allow us to have a signal here that makes our audio driver function. All right, let's take a look. Take a look. Yeah, each one is its own struggle. You just kind of have to go through the paces, troubleshooting. Come out on the other side victorious. Power on. Something's happening there. Something's happening there, but it should look like, I guess it should look like that. No, I thought it should look like an actual triangle. Let's try the output cable. No and no. Okay, so now where are our problems? Where are our problems? Let's check our digital inputs. What the heck is going on? Oh, I see. It's just very, very small. That's only 500 millivolts. What's going on with that? Why does my wavetable not come back? I say, hey man, nice shot. I swear the regulator is going into shutdown. That's good. Albeit a little bit quiet. That should be at 3 volts. That is weirdly quiet. Why would it be so quiet? It's quiet over here? It's quiet over here. Is this one outputting? Yes. Double yes. No. Yeah, there's the triangle. There's my sign. There's nothing. Correspondingly, there's also nothing. I should have saw teeth coming out of this one. That one's there. This one is missing. That one's there. Okay, so it looks like my D input is not quite inputting, which could be on the microcontroller side. So this wire is which one? It's all bad soldering. It's D in, but I'm not getting. D in's the yellow wire. Yellow wire is here. Well, that one's got plenty of data on it. And then the other one's here, pin 5. Pin 5 has not much going on. So if D in is in fact pin 9, or D out to whatever the thing is, then we're not getting it over here. And it is 2 pins down from the blank one. Blank one, pin, then D in. Turn this off, burn myself in the hand again. Ah, damn it. Part of the board's really hot. Okay. Center one here. Blank. Thingamajig. D in. Was this not making good contact? Or is my wire somewhere severed? Oh, it's definitely in there. So does that wire somehow have a break in it? Well, let's just check. Make sure there's plenty of solder. Plenty of solder. I have the best solder. No connections. No connections. No connections. Oh, little connection. Possibly. Possibly just grounded the pin. But then why would I have seen it over at the microcontroller? It did seem like there was something there, though. All right, let's try that. I have to get out the ohms meter if anything else is wrong. That would be here. Nope, still nothing. Yeah, it's still dead. And then if I go to DN, nothing. This one, something. All right. So could it be that I severed the line on the way over? That one goes up, 9 goes down and over, and it doesn't go very far. It just has a little jump right there. But it's possible that part of that wire is broken. Ah, damn it. The voltage regulator got me again. Every time I lay hands on this thing, I seem to, this might be it. The jacket of the wire may have melted to its neighbor and caused a short. This happens with a wire wrap wire. Yep, there it is. That's our short right there. Now that I've done that, perhaps DN works again. God, that stupid hot fucking regulator is killing me. Let's reset. Well, the line vanished. To where? I do not know. Let us take a quick little read here from ground. See what's going on the outputs of this. Nothing. And nothing again. In. It might be that there's a line severed then. Oh, that's not DN. DN right here is dead. Yeah, it could be that the wire is actually severed at that crossing. All right, so I'm out of time. It's 5 o'clock. It's closing time. I guess tomorrow we're going to do more of this troubleshooting. We're just going to get through piece by piece, and you guys can see the kinds of things that I look for and how I sort of troubleshoot around problems like this. Thank you for joining me. I don't know where to deposit you guys. Let's just check to see what's going on over on Twitch tab. I have a notification. Shared viewership is here. What? Shared chat now unlocks combined views. What the hell does that even mean? Twitch charity stuff. Proteus, thank you for the resub, and Fatanon, thank you also for the resub. Oh, we've got very few viewers. Thanks for Stren. Yeah, I appreciate you guys being here. I will be back on Friday. We're going to work on more of this stuff. We're troubleshooting our way through this thing, and then we're going to maybe explore typing up some menus, if I can be forced to do that. But until then, stay warm and stay out of trouble. I will see you guys tomorrow. Oh, I didn't program the end card. Just whatever. Follow me on things. Don't worry about this timer. It's 3 days. Wait, start in 3 days. When did that get set? Oh, 43 seconds ago. Yeah. It's a little snarky when we go over time. 3 days ago is his last stream. But next stream will be tomorrow. And I'll catch you guys then. Thank you. Thank you. Thank you. Where is the button? There it is.